जॉर्ज टीवी आउट 1 ये डाल देना टीवी हाँ टीवी का आउट
सर नॉर्मल नथिंग
मैजिक It's just a disaster, man.
Yes.
But anyway, let's start this meeting. I need the internet. Wait, I want the internet first.
Sir, they take it from me.
What is the Wi-Fi over there? For what we have? What is the password for the Wi-Fi?
STC.
This one, right? Put the password. You done? No, keep. No, you might need to copy paste. No.
I took it from Aman's place.
Okay.
After the site. I need to go Hall C and check. There is also laptop is there, right?
Hall C.
Hall E. Hall E.
Hall E, but that is for the afternoon level.
Afternoon,
Thing.
yes.
So we have time. This I saw in the tickets for change. Poha was there, but it's not no more. It's no more there. It's still there.
Poha production change.
I didn't see. It's not available for me.
There is the change.
Under change, no. Under change, it's not available. That's what I'm saying.
Okay.
Get this out. Remove this. Put this inside. Don't finish the network. Let it go on Wi-Fi. Okay. Join with audio.
What about HDMI? No.
तो हाँ जी एक मिनट join with audio camera okay camera is good microphone test 1 2 test 1 2 Just 1 2 okay we're good to go I'm going to share the screen okay
Raj. Test hello. Test hello.
you copied here
Yes.
which one
First is Hall C.
this one
Test hello. Test.
Let's hide this. This has to be hidden on this. I don't know how to communicate this.
Hello test.
इसको ये डाल देना भाई ये स्क्रीन सेवर डाल देना यूट्यूब पे
One more. Where it is? No. Everything is for the day to
As you know, we witnessed rich activities yesterday from keynote speakers and the technical session. So it was a wonderful day, and at the end, the gala dinner. So now we are going to start with our first keynote speaker today. The keynote speaker is actually from the University of Glasgow, and Dr. Ali Imran. He has some rich experiences, both in academia and R&D, and he has more than 150 research articles published in very top journals and conferences. And he is actually a founding director of something called AI for Networks, where he developed a technology called TurboRAN. This is an AI-based zero-touch network automation. And he is extensively involved in different type of activities related to research or guiding students, final year projects, and the keynote speaker, and many, many different activities. Today, he will be talking about IoT, and which is the topic is Leap for IoT. So I welcome Dr. Imran to the stage to deliver the talk.
Good morning, everyone, and thank you for the invitation to be here, and thank you for making it early morning on the second day of conference. I will begin actually by a brief introduction of the group to which I currently belong, because I was asked to do that before I start my keynote, and then I will come to the problem I will be discussing. So currently I'm at the University of Glasgow. It's actually quite historic university in the sense that it's one of the fourth oldest university in English-speaking world, and in terms of its prestige, it's among the top 100 universities, and more than 8 Nobel laureates actually are linked to the university, and it ranks quite high in terms of sustainability, which is a keyword related to the topic of the conference. And in terms of group, we have, I think one of the probably most rapidly we can probably be in Guinness Book record for the growth rate of the group within 5 years, from 5 members to 120 plus members in the CSI group. And a lot of impactful work is happening there. So the purpose of that introduction was to tell you that whatever I'm going to present is actually acknowledged to a set of groups, set of people. So the problem I'm going to discuss actually can be summarized as a $1 trillion problem, because if we look at the operating cost of the networks around the world which support IoT or mobile communication, that exceeds $1 trillion per year. That's a big number. And most importantly, a lot of that number is actually operational cost, which comes from the energy consumption. And as we are moving towards 6G and beyond, and then Internet of Everything, not only it's the capacity in the network which is choking, but also it's the diversity of the quality of experience, and on top of that, the profitability. But most importantly, it's the technical complexity and as well as financial survivability of the future network, which hinges on something more than just a new technology. And the reason the IoT is actually causing more challenges is because of the diversity of the requirements which we expect, starting from the smart wearable sensors all the way to smart bins to Industry 4.0. So applications here are only limited by imagination. So we are looking forward to Industry 4.0, powered by mobile networks, wireless communication, smart city domains, and then well-being and health. So the use cases, there was a question in the panel yesterday that what we can anticipate in terms of new use cases from IoT. So the answer to that simply would be the applications or use cases are only limited by imagination. If we want to understand how and the scale of that statement, then we have to go back to the history and remember that Faraday was asked that what is the use of electricity when he invented electricity, because people said you cannot see the thing, and if you touch it you die, and there was no electric bulb, there was no electronics. So same thing is going to happen with the mobile connectivity, but the picture is not rosy on the other side of the equation, which means we have only 3 possible ways of actually improving network capacity, network actually performance, and we have exhausted over the past half century almost all of them. So what's the solution? The solution actually requires addressing another daily problem. Yesterday, there was a discussion around this. We still actually are living in an era where the networks are designed and then they're left to their own devices. So this is a traffic pattern in one particular city, and this represents almost all the cities around the world where the traffic changes in 24 hours or over the week, but the network does not change, which means if we translate this, the inefficiency that leads to about $1 billion per day loss in terms of efficiency, resource wastage, let it be the cost of the spectrum wasted or let it be the energy wasted. So that's the inefficiency which we are dealing with at this moment. So if we combine these 2 problems, and then look at how we are currently operating the mobile networks, then we'll see that this is a significant problem. While we can actually be excited about the applications, the network actually requires fundamental paradigm shift. So this flow chart shows that it takes about a week to actually update the network with the current approaches without the AI. And compared to that, as we could see in the previous slide, the traffic was changing very fast, 24/7. So what's the possible solution for this? The solution for this is actually fourfold. We call this framework LEAP. So in future, the network have to be lean, elastic, agile, and proactive. So this is quite opposite of what we have. We have heavy design, we have inelastic networks, we have networks which are not agile and reactive. So to actually break it down, there are going to be actually 4 key enablers. Zero-touch automation is number 1, and then we need to have more energy efficient networks, and then Open RAN, and then non-terrestrial networks are also part of the equation. So we don't have time to go through all of them, so I will be focusing on this particularly, and the reason for that is twofold. First of all, the zero-touch automation is enabler for the other 3 enablers themselves, and secondly, this is interesting problem in this because that's where the AI can make a big difference, and that's a bottleneck if not solved. So compared to, let's say, 4G, where SON was just good to have technology, for 6G, and this is essential technology. So what is zero-touch automation? So the idea of zero-touch automation is not new. So about 2 decades ago, the concept of SON was proposed, which is self-organizing networks. And then in one of our papers, we proposed the idea of data-driven, AI-driven networking in 2014, more than a decade ago, and since then it has become a major theme. But the question is that if it has been there for more than a decade, why it hasn't been realized that? So the reason for that is multifold. The key problem is the complexity of the mobile networks, and there are challenges which stem from the number of parameters. In 5G, we are talking about 2,000 parameters per site, and then that number is expected to grow with 6G. So out of those challenges, I'm going to focus on one particular challenge, and that is that we do not, if we want to use the AI-based zero-touch automation, which is essential, we must have to do that, but we do not have the training data. So we have a major challenge, training data scarcity or TDS problem. And I'm not going to go into detail. There is a very detailed survey we recently published with Ericsson, where this challenge is looked into in detail. But the bottom line is that this challenge is often looked in the literature. So there are thousands of publications since that first paper, or one of the first papers a decade ago, which have looked at zero-touch automation, various problems which can be solved using AI. But most of those publications actually assume there is plenty of training data, which is not the case in real network. We do not have enough training data. We never will have because of the reasons of combinatorial issue. Yes, if we have 2,000 parameters, each of them have 10 possible values, the number of combinations will be more than atoms in the universe. So we'll never have enough data when it comes to mobile network training. This is very different than images, vision, computer vision, or other fields where we have plenty of training data. So here, so to understand the implications, so this is, let's say, accuracy which would be reported in a typical paper using a deep neural network for predicting path loss or radio propagation when there is 100% training data used. 100% means the representative data from the coverage area is used. And then when the realistic data is used, the performance drop significantly. So richer the model, the more expansive the model in terms of number of parameters, fancier the model, more training data you need, which means this performance will drop substantially when that model is taken out of the paper and then used in the field using the real amount of training data. So another example here is that, so there are papers including ours which will assume that you can detect a range of faults or develop self-healing capabilities from the RF map of the coverage area. But usually these papers would assume either data scale available at this scale, or this scale, whereas in reality we will have data less than 5% of the coverage area. Okay, so what's the solution? Okay, it's early morning and I want to make sure that everyone is awake. So what's the solution? Any guess? GANs, LLM, deep learning. So we do not have enough training data, yeah? Synthetic data, yeah, that's a good point. So for synthetic data, actually, we need GANs, yes? That's what you're saying? So to train GANs, we need seed data, which means we need real data. And if it's not representative, we will have mode collapse, we will have convergence issues. So the GANs will not take you where we want to go. We have discussed GANs in detail in the survey paper, but unfortunately, given the challenge which we are facing, GANs also require some initial data, and LLM, we all know, require even more data. So deep learning, I already showed you. So the solution actually comes from a phrase which we have been, anyone who has been in London Metro, there is a sentence which you would be hearing all the time, mind the gap, which means when you are trying to step onto the train, there is a gap between the train and where you're standing. So mind the gap. So the idea here is that we actually are living in a paradigm, AI-driven paradigm, where the success has come from the deluge of data. The entities which had access of plenty of data actually made it powerful enough that we are not minding the gap. The gap exists between the natural learning or the actual intelligence which biological systems exhibit and the AI which we currently practice or use. So what's that gap? The gap is that in AI, we have one-stage learning, which means we arbitrarily design a neural network, neural architecture, and then we throw up plenty of data on it, let it be synthetic or real, and then we expect it to yield the sensible results. The sense which it will extract would be as sense and common sense as the quality of your data. If you don't have data, then you don't have the common sense in your neural architecture. Compared to that, the human learning actually unfolds in two stages, nature and nurture. The first stage comes from the architecture itself, the connectum. The human brain at birth is not a tabula rasa. So you can call it intelligent design by evolution or the DNA wires it in a certain way. The architecture is not arbitrary, it's not randomly initialized. And then on top of that, we have nurture, which is the second stage learning, and which means exposure to the training data. So if we compare it with the current neural net architectures, then we are relying only on the second stage where we are exposing arbitrarily designed neural architecture to plenty of training data, and then we're expecting that it will be as good as the actual intelligence in biological system. So we are missing this part. So that was the motivation. So we have actually proposed a framework to address this. The idea is that while we cannot rely on the genetics in our neural architecture, synthetic neural architecture, we can rely on something called domain knowledge. So in many domains, including wireless, we have plenty of well-established, mature domain knowledge, and that means we do not have to start with a neural architecture which is tabula rasa. We can start with a neural architecture of an infant, which means there can be instincts in the neural architecture. So how do we do it? So up to this point, let's say this is the kind of neural architecture which we mostly use. So there is input, there is output, and there would be arbitrarily designed neural architecture through heuristic or hit and trial, and then you throw a lot of input data. There is a loss function, you can play with that, and you will have an output, and when it is desired output, you are happy. But is it interpretable? No. Do we have the robustness to the scarcity of training data? No. So it doesn't address a lot of questions or concerns we have in wireless, as well as in many other domains where we do not have enough data. So the idea is to actually fuse the domain knowledge here through analytical equations. So here is a simple example. I will not go into the detail of the math. So this is one way of embodying the domain knowledge. So there are many ways to do that, but one of them is actually you start with the very crude model of your system where you want to operate your model, very crude. It doesn't have to be accurate. And then you, from that model, you unfold a neural architecture. So you don't arbitrarily pick up a neural architecture. Your neural architecture, the layers, the activation functions, the connections, everything will actually be inspired from your domain knowledge. So this is different than physics-inspired neural networks, before anyone is wondering, where you actually insert the boundary conditions. So once you do that, then you will end up with a neural architecture which is like connectum of a newborn, which means it has the instincts about the system which you have, where you want to train your model. And once you do that, then you can see the difference in the performance. So this is, let's say, a typical city where we want to predict the coverage. One of the challenging problems in mobile networks is predict coverage because there's a lot of randomness. And usually this is the amount of data which would be used in a typical academic paper to predict the coverage. But in reality, we will have only this much data because you would be doing the drive tests and you would be doing it only on the major roads, and even this probably would take you weeks to gather this much data. So we want to see that if we train a model on this data and this data, what happens? So here is the rich data. So if we look at this, then the error is actually the lowest with the black box model. So the conventional approach gives you the lowest error, and then analytical models are way off, which means your domain knowledge is not perfect. And then proposed approach has slightly or significantly higher error. So up to this point, it doesn't look promising. But the fun begins when you use the realistic amount of data, which I showed on the previous slide on the right side. And then you see that the error of the classic AI increases by 22 folds. This is something which would not be reported in a typical paper. This is something which would be observed when you try to take models from a typical paper and use it in the real world setting. So 22-fold increase in the error, and compared to that, in the domain aware or the double N AI, which I call double N, which is nature and nurture inspired AI. Here the performance actually holds pretty well. So this was the simulation-based validation, and then we validated it on a test bed as well. So where we use the data from one side to predict the other, and then this is the result where we got, which is quite like almost overlapping with the actual data. So the conclusion here for this particular insight is that we need a paradigm shift in the current AI, where people are moving towards LLM and bigger and bigger models. However, this leaves behind the domains where we do not have plenty of data, and one of them is mobile networks. We do not have enough data there for training the models, as well as for many smart health applications. We do not have enough data because of the privacy concerns, as well as the rarity of the diseases and many other reasons. So for those domains, we need a new kind of AI which can come from inspiration from nature and nurture inspired two-phase AI. Okay, and if we do that, then we'll need far less training data. It will be interpretable, has intuition before exposure to training data, and simplifies the hyperparameters. Okay, so I have about 15 minutes, so I can go through a couple of case studies. So what can we achieve with this approach? So one case study I'm going to present here is network antenna parameter optimization. So previously I showed animation. So if we want to optimize an antenna in a network, the flow would look like this. You would have to actually gather drive tests or field measurements for a couple of days or a couple of hours. Then someone have to do the performance analysis, new parameter calculation, and then the configuration. So it's the life cycle of this approach is minimum few hours, if not a week. Compared to that, you start with a crude model, and then you are able to actually come up with and then you do propagation modeling using the same approach, and then you can have automatically adapting antenna parameters in a cluster of cells. And the advantage of that approach, if I can play, yes. So as the traffic, I remember I was showing you a slide where the traffic was changing in city of Milan. So as the traffic would change, so the network will adopt automatically using that approach, because you have a very lightweight AI running in an agile way and elastic, and it is making the network elastic. Okay, so another case study is, so this was the problem where we were wasting a lot of energy. And the typical approach here is that you just want to shut off the sites. But if you do that, then that will be done at the cost of the quality of experience, because the base station have to come up again, and it will take a couple of minutes for it to come up again. So how do you do that? So you do it using the double N AI, the AI which I proposed. The idea there is that the base station and the traffic would be predicted in the runtime using the mobility pattern, as well as the previous training data. And then the base station would be proactively switched on and off, which means anticipating the traffic, the base station would be switched on 30 seconds or 15 seconds before the traffic is going to be there. And as a result, we will not have a loss in the quality of experience. So this was one of the winners in IEEE Green ICT International Competition. We received an award for that in Paris as a best solution proposed by any team among among about 30 plus countries representatives. Okay, so one more thing I want to highlight is that for this work to be this kind of AI to be validated, the test beds and real data is needed. So we have been using the test bed at multiple locations. This test bed, which was briefly mentioned, Turboran at OU Tulsa, which we built, and then test bed at University of Surrey. And then we have a custom simulator to develop the seed synthetic data where we need. Okay, so that brings me to the the end of the first part of the talk, where I have been looking at the applications of Neo AI or double N AI on the mobile networks, how we can achieve zero-touch automation to enable the S4 IoT. S4 IoT means the sustainable, scalable, secure IoT. But once we have that, then let's say we have the connectivity, omnipresent connectivity. This is all what we can do, starting from the Industry 4.0 to smart cities and well-being. So while we cannot go into the details of all these use cases, so I will highlight one particular use case, particularly in the wake of recent trauma humanity has received. All of us still have PTSD from COVID-19. So one of the challenges, actually, we have systems to predict earthquakes, we have system to predict tsunamis, but we do not have system to predict pandemics. So that was something which we tried, and we succeeded and make quite a splash around the world, and now there are major initiatives to actually build on that. The idea was that can we use the omnipresent smartphones to screen for COVID-19, and that's what we were able to do using the Neo AI concept. Only from the 50 cough samples, we developed this app where you cough into a smartphone and you could, the AI would tell you that if you have COVID or not. This was reproduced by MIT, it was reported in Spectrum, Nature News, Voice of America, and recently Google has actually reproduced it for TB using data from more than 60,000 patients. Okay, so, but the thing, people must say, okay, why it's relevant anymore? The pandemic is not there anymore. So anyone who is into epidemiology, pandemics is only a question of when, not if. So it's just a matter of when. So pandemics have been there, will be there. There is no way to avoid them unless we come up with a system to predict a pandemic in phase 1, which is this local breakout, and then you can stop it from becoming an epidemic and pandemic. So you have to have a system to predict a breakout. But at this point, the issue is that if you have a infection, the way to test it is very sluggish. So it will take days before that data can be gathered. So the framework which we propose here, I predict, is a baby step towards that direction. The idea is that using the variables, we can actually create a profile of existing, a baseline of the diseases, and then from there you can actually predict if there is a outbreak, and then it can be scaled. But this is just an idea. We have validated some small pieces of this bigger framework. It will take a village to take it to realization, probably a decade of research and millions of dollars funding, and probably teams of tens, if not hundreds of scientists. Okay, so more specifically, I can give a use case of smart IoT which focuses on another $1 trillion problem, the chronic respiratory diseases. So many people actually are not familiar with the fact that the chronic respiratory diseases are the third leading cause of death worldwide. The number 1 is cardiovascular, number 2 is diabetes, and number 3 is, so number 2 is cancer, and number 3 is chronic respiratory disease. So while we have a lot of solutions for cardiovascular disease, you can measure your blood pressure using your watch, and glucose can be measured at home, but we do not have any way of measuring the health of lungs or respiratory disease or the state of the respiratory disease or prediction of its exacerbation. As a result, in USA alone, every 4 minutes, 1 death happens, preventable death, because the exacerbation of asthma or COPD goes unnoticed, and people end up in the emergency room causing, and that has cost humanity about $4 trillion in 10 years. So this is a solvable problem, but the approaches so far have been something like this. So if we want to solve this problem, then we need three things. We need to monitor, like screening. screening for the respiratory disease. Number 2, we need to manage the medication. Number 3, we need the preventive care to avoid the exacerbation. So if you look at the pillar 1, the effort, so this is one of the recent papers examples. So the effort to monitor the symptoms in a respiratory disease look like this. So you have to wear something like this. Imagine you have asthma or COPD, and then you're expected to wear this on your chest to monitor your cough. And then academia is trying to solve that using even more interesting solutions where you have to put a strap on your neck. So this is a paper recently published in a reputed journal. So, or you can maintain a symptom diary like this. So this is the current solution in symptom monitoring. Medication management, 70% people fail to properly use inhaler or forget to use inhaler, and then these are the solutions which exist in the market, starting from a $5 add-on onto your inhaler to a $600 smart inhaler, which will last for 3 months. So these are the existing solutions. So compared to that, actually, we have come up with using again smart IoT, biosensing, and smartphones or your smartwatch. So you don't need smart inhaler or any of those add-ons or put something on your chest. All you need is to wear the watch or carry a smartphone with you, and then your cough or respiratory symptoms will be monitored, and your inhaler will not only be monitored, but you will get the guidance on the use of the inhaler, correct use of inhaler. So this can be downloaded from App Store. At this point, this is in experimental phase. It's not regulatory clear. It is going through the regulatory clearances, but we'll appreciate the feedback on this. So this is one example where the existing sensors, one of the most powerful sensors we have is actually in everyone's pocket. So a smartphone, so it has a lot of sensors. So from there, we can extract all this information, which can help us monitor, prevent, and manage respiratory conditions among many others. Okay, so I am ending my talk here. The conclusion is that the applications of the the IoT or what we can do with the omnipresent connectivity they are limited only by imagination. So the same way no one could imagine the applications of electricity or fire. But unlike electricity, we have a challenge of actually limited energy as well, but in wireless or mobile communications, the challenge is more fundamental, where the spectrum is limited, and we have exhausted all possible ways of actually increasing the capacity and performance. So the most of the performance has to come from zero-touch automation, which further requires training data, which we don't have. That means we need fundamental breakthroughs in AI, and one of them can come from looking at the biological AI, where we have 2-stage instead of 1-stage AI. And once we have a ubiquitously connected world, then we can have a variety of applications, starting from the Industry 4.0 to smart health. And within smart health, I presented a use case which can have a global impact, starting from predicting future pandemics to actually managing chronic diseases which affect hundreds of millions of people worldwide. But it's very hard to predict the future. Only way to predict the future is to create it, so let's create it together. Thank you very much. I have deliberately left time for the questions.
Thank you very much, Dr. Ali, for this nice talk. If you have any question, the floor is yours. Anyone has any question? Yeah.
Thank you, Professor, for a wonderful talk. I have some questions, basic questions related to medical imaging. One of the biggest challenge what we face in medical imaging is the data sets. Sometimes we get a limited data, sometimes we get a huge amount of data for a given application. So when we have a small amount of data, people mostly use augmentation, and they rapidly increase the sample from a few hundred to few million. So in this kind of environment, how do we design a network? Is it a valid approach of augmenting a data of enormous value? What is your opinion?
So, so there is a saying in data science or AI that in God we trust, everyone else bring data. So the point is that your model is going to be as good as your data, but it's not the volume of the data, it's not the size, it's the representativeness. If you have, let's say you have 100 samples, but they represent the distribution of the system which you are trying to model uniformly, they are gathered uniformly across the distribution, they would be good and augmentation will work. Okay, but if you have 1 million samples and they are, let's say, 20% of the distribution, even if you augment or don't augment, doesn't matter, your model is going to be biased, skewed, and it will not generalize. So it's the quality of the data, is it representative or not? But then it's a chicken and egg problem, how to check whether it's representative or not, because you will not know the distribution unless you have a representative data. And this is where the domain knowledge comes into play. So domain knowledge will help you to understand if your data is representative or not. If it's representative, then augmentation by all means. GANs and auto variational encoders or whatever you throw on them, probably you will have a reasonable improvement in performance. But if it's not representative, then your hands are tied, you are thrown in ocean, and good luck with that. So then there's nothing which you can do with that data to get magically result. But the way to overcome that is there if you have a domain knowledge which you can embody into a mathematical equation, and then you can use the framework which I just presented to actually have a neural architecture which embodies that domain knowledge. So which means it knows the principles, the physical principles of your system. Okay, and then small amount of training data will help you to actually have intuitively better results. Yes. So the example for that is, for example, a human brain has specific neural centers, circuits for numerical analysis, for number theory, and for physics like gravity. So even a small baby would be surprised, even when they cannot speak, by analysis of their gaze, you can see that they get shocked if a thing which is physically tangible penetrates another thing which is physical tangible, because they have the sense of matter and also the gravity. If a material thing, instead of falling, if you throw something, instead of falling, it hangs in the air, the baby will be shocked. It means they haven't been exposed yet to any training. They haven't been taught the Newton's laws of physics, but they have the intuition. That intuition is coming from the connectome, the wiring of the neural architecture. That's what we try to do it here. But it's not possible in all domains. It's only possible if you have mature enough domain knowledge to mathematically model or model it through, let's say, pseudo-mathematically, the domain knowledge in the architecture. Yes, and then still there is a limitation because not all principles can be translated into a neural architecture.
Thank you, Professor, for walking through. It was great. I'm not into healthcare, but all of us go through various issues in health. My question is in terms of the data itself, right?
Mm-hmm.
Typically, if you take, may not be just one disease, right? Different patients may have different combinations of it. How do you actually identify and create different scenarios, right? Because whatever you want to predict may be dependent on various other things that are happening in the body.
Yes. So that's a very good question, and that doesn't actually go with your first comment that healthcare is not your domain. So this is a question which a domain specialist would ask. So that's why when we published this paper, so the cough-based diagnostics, yes, so in this paper there is a table which lists the 28 different diseases in which cough can be a biomarker. So unless you have the training data from all those 28 diseases, you cannot have a diagnostic capability. But we didn't try to achieve diagnostic capability. We tried to achieve what we call screening capability. Screening is one step before diagnostics, where we are not pinpointing the disease, we are pinpointing a lung anomaly, a respiratory anomaly. And on top of that, what you can do is actually, so you might not have data for all 28 diseases which will lead to a lung anomaly and then can have a signature in the cuff. But if, let's say, you have data for COVID, and then you are looking at the CT scans for the COVID infected lungs, and then CT scans of asthma, COPD, TB, bronchitis, bronchiolitis, all of the 20 diseases. And then you see there's a difference in pathomorphology. And that difference, you can intuitively kind of assume that will translate into a unique cuff signature. So then you can train a model not for anomaly detection, but to pick the cuff signature unique to your disease. Then probably you will have better accuracy. But of course, it will require the domain knowledge, the expertise, that what are the confounding variables. Yeah. Any other questions?
I have another question. So
Yes.
Thank you very much for the very nice talk. The broad applications and the involvement both with academia and industry is really impressive. Now, when it comes to communication, you talk about 5G having around 2,000 parameters to manage. And you know, with some ultras application where you need like very low latency, applying this leap solution and machine learning, do we have now the tools to make a decision in a way that you don't violate, let's say, the 1 millisecond kind of end-to-end latency? Are we there?
So, in the interest of time, actually, out of the 300 slides, of maybe 1,000 slides, I picked up the slides which I could fit. I wanted to leave time for the answers. But if you look at our publication, so there are tiers. So first is reactive self-healing, yes? So that's a 1 minute latency compared to 1 week. It used to take 1 week to come up with, to fix a problem, yes? Now you can do it with machine learning in 1 minute. But then there is a next level where you can use this agile AI, or the Neo AI, or double N AI, which will do it in seconds. But still it's not 1 millisecond, because 1 millisecond is in some cases longer than the propagation delay. So for that we have a third tier, which is called proactive. So leap, the last P is proactive. So what do we do here is that actually we predict the faults. We predict the faults by historical data, as well as the transition probabilities, hidden Markov chain models you can use, where you can predict the most likely failing cells. And then you proactively go ahead and do the tuning. It's like, would you wait for your car to actually stop on the road? You will take it for maintenance before it happens. So that's what we try to do, having a maintenance schedule for the cellular networks. And that can lead to one aspect, solving one problem in the millimeter wave, ultra low latency. But ultra low latency is I would say it's a pipe dream for 1 millisecond, because in many cases, the moment your total distance you have to travel is more than 300 kilometers, you cannot meet it. The propagation, electromagnetic, fundamental law of physics, speed of light, you cannot actually do it in less than 1 millisecond. Yes, I hope, yes.
Thank you very much, Dr. Ali, for your presentation. And I will now call upon the stage Dr. Tribulsi to hand your token of appreciation to Dr. Ali.
Who is doing this? Someone has control of my presentation. Okay. Okay. Thank you. Thank you.
Now let's start with the first panel discussion of the day. Dr. Ziad will moderate the discussion. Okay, welcome.
Thank you very much, Dr. Murad. Yeah, so I am Dr. Ziad Bouida. I'm with KCST, and I will be the moderator of the second panel today. So why we selected this title? The title is basically inspired by the talks given by the keynote speakers, and also It's related to the Internet of Things. So the plan for our panel today will be as follows. I will start with a 2-minute introduction. Then I will invite the panelists. We'll have questions. And what we'll try to do today is to have you involved in this discussion, because our topic is about smart citizens. So we had a very interesting panel yesterday about the Internet of Intelligence of Things. So having Internet of Things is great. We have it everywhere. A very good comment was made at the opening ceremony that Internet of Things is relevant and will be relevant for the many years to come. Now, when it comes to Internet of Things, anything that is connected is included under the Internet of Things. The name and the Internet of Things may be seen in the literature and under different names. Internet of Everything, probably this is used mainly now for 6G, but also historically the wireless sensor networks, recently the Internet of Drones, and very interesting research topic, recent research topic, the Internet of Sounds. You may be very interested about this new topic. There is a conference, actually, IEEE conference about the Internet of Sounds. So the things are talking to us, they're becoming smarter, but what if we can make out of these smart things smart citizens? Because at the end of the day, it's about us, students, researchers, people, and citizens, elderly, all inclusive, like including all the society. How can we make this Internet of Things for smart citizens? So without further ado, I will invite our 4 keynote speakers to join us on the stage. Yes, please. So the 4 keynote the 4 panelists include 3 keynote speakers, and also we have our 4th panelist, Mr. Sudhakar Nibhanu-Pudi from NBK. So please join us. So you can sit here. It's your seat here. Dr. Filali. So before we start, a very fun but interesting fact. Professor Filali and Professor Menshai went to school together in France 20 years ago. And Professor Amran worked with Professor Filali in QMIC. So we have a reunion here, and with a great addition from NBK. So quickly introducing our panelists. So we start with Mr. Sudhakar Nibhanu-Pudi, is the Group Chief Data Officer at NBK. So we'll elaborate more on his profile as we go with the questions. We have Professor Filali, the Director of Technology and Applied Research at Qatar Mobility Innovation Center. He gave a really interesting keynote yesterday. And our 3rd, we have you, but just to make sure they give you the right, Professor Muhammad Hussein Menshai is a professor of computer science at the Hunter College in the City University of New York. And he has also gave a very interesting keynote about several applications related to generative AI, and we'll talk further about these applications. And Professor Amran just gave an amazing keynote about leap networks. Actually, the title for today was mainly inspired by your title of the keynote. So let's start with the questions. So we have like 4 rounds of questions. And please, as we discuss, try to think how this topic relates to you as a student, as a citizen, and prepare your question. We'll also give you the chance to ask a couple of questions. So we'll start with the first question. Basically a brief introduction, but mainly we want you to highlight what type of IoT applications that you do for smart citizens, like a smart city and smart citizens in general. So IoT applications and the relevant to the topic. We'll start with
okay. So as I briefly outlined, so personally my interest is actually bidirectional. One is on the expanding the applications on the connectivity and making it ubiquitous. The other one is actually, once the connectivity is there, than applying it for the healthcare. So that's where my latest interest is. And in terms of IoT impact, other than Industry 4.0, I think the healthcare probably has the highest potential because humanity's biggest challenge is now probably in this domain.
Yeah, thank you so much for introduction. Regarding your question, I should say that basically it's a few years that I just focused on generative models, and for these particular applications, I can mention first of all security. So when we have huge amount of data in infrastructure, like the example that I had it yesterday for smart grid, it's very important to predict any possible attack to those systems, given different type of security and vulnerability issues that we have in the network. So generative AR could be useful here to predict and generate those attacks that we don't know in the system. So that's one thing I'm working on. And the other thing is wireless planning, that is somehow related to a very amazing talk that we had today, Dr. Imran said. We would like to apply generative models to predict wireless signal in different environment under different conditions, and also new protocols that are going to be designed in future. We would like to predict what would be the behavior of the wireless signal in the physical layer, giving us a good feeling of quality of the signal in different environments. Like that, we can better organize and plan our wireless network to get more and more efficient network in different environment under different protocol. And be careful in the new protocols. We have lots of sharing frequencies when we have different protocols coming in physical layer in different applications. So it would be great if we can have generative model predicting what would be the performance, also helping physical layer to better decode the signals in different environment to get more and more efficient application.
Professor Filali.
Yeah, so Internet of Things is really the core of our business at Qatar Mobility Innovation Center, and we started working in many applications and use case, I think around almost from day one in 2010. So it's about really connecting the infrastructure to the, to your backend and start collecting data. That infrastructure can come from the road network, can come from industries. We're talking about Industrial 4.0. We can think about agriculture applications as well, healthcare and so on. But in addition to what I mentioned yesterday during the keynote, as example is related to the traffic management, and where we have 400 sensors deployed in Qatar and collecting the data real time. We're talking about billions of records every day, and trying to translating really bytes to insights, and insights to services, right? And services to applications that the end user can use. And with AI and generative AI, potential is really high, where you can predict what will come in the next 30 minutes about the traffic, about predictive analytics for industries, but you can also run what-if scenarios with generative AI. Once you have historical data, city planners can really do a lot of what-if scenarios and act on the real time by fine-tuning the signal times of signals and so on. One extra application we did in the past and during the World Cup is smart parking, where you have a lot of parkings. They have their own system running, right? But you need really to, when you reach the parking, you see the capacity of the parking, the available spots, and so on. So our idea really was we started this in 2017-16, is to connect this parking, right, to our mobile application, WAN application. So we had to develop a gateway, IoT gateway, and connect to the existing parking. So we don't touch a legacy system, just connect to them and grab this information and send it back in real time to the applications. So we connected most of all parking in malls, in most of the places in Qatar, And so people, they can really see the parking availability in their mobile app. So we're bringing the information to the end user. This is another example. Another system that we started 2-3 years ago is to help smart cities in Qatar, like Lusail. Lusail is a new smart city in Qatar, which was built really from the ground up for the last 10 years, where you have the iconic stadium, Lusail Stadium. So we are talking about around 200,000 inhabitants there. So they came to us to ask us to automate the process of inspections, because they have inspectors working 24 hours and trying to detect any anomalies in the infrastructure. So what we did, we just using a mobile app with the camera pointing to the road, and then we collected video real time, video streaming in real time, and in the back end we developed AI models to detect anomalies about potholes, about street lights which are not working in the night, about the vegetation index, what we call vegetation index, to look at the greenness of the streets and give them some indexes and so on, and many other use cases. So here we are talking about real-world applications, which are really taking research to of course, to real-world applications and products. Okay.
Thank you, Dr. Zaid and fellow panelists. Firstly, thank you for inviting a banking person. I don't think many would associate IoT devices with the banking, but I'll try to give few examples as to how IoT is very much integrated, right? So if you take any smart city, the way Professor Dr. Fetty was saying, what do people need? People need to be able to integrate banking into whatever they're doing. Nobody wants to go to a branch. Nobody wants to call somebody, right? I should be able to do everything. So there has been a lot of transformation if you look at banking as to how to make it invisible, right? Almost invisible, that you are just doing on your phone something else and then you can do it, right? So if I look at the applications per se, as we move into the digital world, if we know, for example, NBK has launched VI Bank, which many are customers of. What happens? Nobody goes to a branch. It's all done through the mobile, correct? You onboard a customer using a mobile. But what else is happening behind the scenes? So when you upload your civil ID, for example, how do we validate it? You connect to the PASI and then check whether the information is correct. Is it expiring? What's happening at that point of time? And is it the same person that is the photo of the person who is trying to create the customer? Is it the same as on the civil ID? So there are various touch points that get analyzed before actually doing it for the customer. I'll give another classic example. Yesterday when I was meeting my fellow panelists, almost everybody is traveling, right? Nowadays, if you travel, literally you don't have to have anything other than your mobile in a banking. I've done many trips where I just did using a mobile, right? Because many places have gone completely digital. But what happens behind the scenes when you are traveling? Bank is actually looking at the geolocation. I remember, I think you were saying that the bank said you don't need to inform me of where you are, right? So you track the geolocation. You're paying through mobile. Is NFC communication, right? You have the POS terminal that you're trying to do. And if you're trying to do it in 2 different locations at the same time, that bank is going to identify it as a fraud, for example, right? And then it is communicating back to check whether you have a balance, you don't have a balance, or somebody else is trying to fraud you, correct? So there's a lot of connectivity that is required to make the life seamless from a banking perspective for the customer. We will try to go through a few other examples later, but the summary is that how can we make customers' life easier, integrate into their personal life seamlessly. That's how I would describe as to our contribution.
Amazing, very, very interesting examples. Now, I will stay with you in terms of, basically, my next question is for each one of you, one by one, I will give you some personalized question about the type of application that brings, that had an impact. So if you have to select one application that made an impact in your career, that was basically the measure or the metric to use, is the benefit to society. Now, I know, Mr. Sudhakar, in banking, there is the new concept of hyper-personalization. So you use the data of users, of our clients, in order to provide them with the best service. So can you mention an example of such hyper-personalization that helps Kuwaiti in their daily transactions or decisions?
So, if I'll take you back sometime. Sometimes when you go to certain airports, right, there will be counters there which will try to sell you a credit card, right? It's this Amex card or whatever, right? Effectively, they're just trying to sell you a product, not knowing whether you need it or not. Hyper-personalization is nothing but what does the customer need at what time. So what we try to look at is classic examples, right? You are traveling and your card is up for renewal, right? So if you are abroad and then the card expires, you're not going to be able to immediately get the card, correct? So, for example, before summer holidays, we actually try to check as to whose cards are expiring and then see if we can basically give it to them before, right? So that the customer doesn't get inconvenienced. If we take that scenario further, right, how do we predict whether somebody needs a limit increase? Maybe you're using your card well and you're paying, which means that if you are completely utilizing it, then we actually predict, maybe we give a call and say, do you need a credit limit increase for it? By the way, this is applicable not just for individuals, it's also applicable for corporates. Corporates, most of them actually borrow, right, to do their financing. So there also we apply the same thing. The logic is that as we go forward, we should be able to predict your life journey, right? Which means that you got your first job. Yeah, okay, we know that you got the first job. That means that maybe you want to do a mortgage later, right? Or you have a child, which means that child might be going to university. How do you predict and then say, what does the customer need? So a lot of things at the moment are still driven by the data that we get from the customer. Obviously, customer needs to give consent. Going forward with most of the Gen AI and the AI stuff, we will be able to better personalize, fine-tune it to the individual customers, much more than what we were doing before. Because till now, whatever data we were using is more of what transactions you have done. But when you give calls, when you do chat with the call center people, we'll be able to capture your personality much better, right, as a customer. So the hyper-personalization journey actually means banking for one customer, effectively. We're creating a bank just for that particular individual.
Very, very interesting. Actually, when we talk about hyper-personalization, we don't need to think of it from one application. So even ourselves, as you think about yourself as a teacher or as a parent, you are collecting data all the time. So even when you in your relationship, when you try to provide a service or a favor to a person or a friend or a child, basically you are learning. So hyper-personalization is a very interesting topic that we apply on a daily basis. But certainly if you have that applied by a machine learning algorithm, that will save you all the energy. So for example, with time you learn that your youngest child preferred toy is a car or Hot Wheel car. So basically your machine learning algorithm will tell you about the next gift or the best gift or the best package or the best holiday destination that you can offer to a family member. So it's a really interesting topic. Now I will mention, Professor Filali, statements yesterday. He said, data is noise until it becomes useful. So this is really an interesting saying. And also another statement that you made like yesterday, from bytes to insights. So the question for you, Professor Filali, can you mention, mashallah, I saw like probably more than 20 products out of QMIC lab or the QMIC center. So what application one of these products you think made the most impact?
Yeah, thanks so much for your insights. So yeah, I mentioned many solutions that we developed over the last 15 years in QMIC. Of course, some of them, they were just failure, right? They stopped at POC or pilot at maximum. As startup somehow, this is expected, and we are successful in others that they made a big impact. One interesting example is in the military and defense, but I cannot disclose what is that. So it was a very strategic one with national entities. But one it is really, I can mention most likely is it made a big impact is during the World Cup, right? Where we are very busy in delivering amazing all of the entities in Qatar, including ourselves. This is about smart parking, but again, we are talking here about temporary parking of thousands of cars around every stadium. So we cannot really, for a single spot of parking, install a device or put a camera or whatever. So we need to control the flow in and out, and given that we know in and out, you can predict the availability somehow around the parking. And we are talking about real-time information. And to close the loop, you need to provide that information real-time to the end user using the application to navigate depending on his ticket type for the match, plus the operators, right? They are in the control room to see what's going on and guide the people on the ground, police and others, to close down parking, to guide them to other parkings and so on. So the challenge was, we had a lot of challenges. Of course, we are talking about the day and night, so we need to make sure to use camera with a standalone system, an edge device with the GPUs, and everything is standalone in terms of connectivity, power, and everything, and install this in all gates. We have a huge parking, so sometimes you have many gates in and out, and multi-cars that can enter together and so on. So you spend a lot of time in collecting the data during the Arab Cup before the World Cup, and training the model, fine-tune it, till reaching really almost 99% of accuracy. Plus then you need the integration with the backend system and applications. We are talking about our WIN mobile applications, so users, they can just scan the barcode and get the right parking availability and be guided to the exact spot of the parking, right? This is the impact. So data, as you said, is just a noise till they see the benefits really to the end user. So the end users, they are seeing the benefit of this data. Plus the operators as well, they know in real time, using a dashboard, the capacity and the availability of every parking around the stadium. So it was a very successful story. So I can mention others, but I keep it for other.
Yeah, it makes complete sense. I'm 100% sure of two things: that it's an amazing application, and you didn't enjoy watching any of the games of the World Cup. You were busy. No. Probably you were busy implementing the solution.
It was already before, so I did not skip the matches. We're able to, the team did a hard job really, and so we had a few operators from team embedded with the team of the FIFA and Supreme Committee of Legacy and Delivery to be able to operate the system as well.
Interesting. Yeah, so yesterday we had a funny discussion with Professor Manshai and the team on the gala dinner. One of our colleagues was hearing voices. He went to San Diego to a hotel, and then he was all night hearing very strange voices. And basically, when he complained to the hotel, they said nobody is living there. So either the hotel is haunted, or that person had hallucination. Why I mention hallucination? Because Professor Manshai, one of his applications, other than application to cancer and other medical field, he deals with or try to resolve hallucination problem, but early detection. Probably I'm giving you the answer for your best preferred application. If this is one of them, please mention it, or any type of application that made an impact.
Yeah, actually, I was thinking about that. You surprised me. Yeah, one of the things that I really wanted to work on that is how brain is working. That's the big question that we had from the beginning, that how our brain is trained, how we can see the objects, and how these neural networks that we have in our brain are perfectly working in a very good way. So after having these generative AI models, and in particular GANs, one of the applications that we started working on is modeling the behavior of different parts of brains with generative AI models. And let me give you just very simple example. When we are watching some objects, you get some signals, and it goes to your brain. In one part it processes, and then it goes to other part, and then the other part says that you are watching chairs, or you are watching amphitheater, or whatever, okay? And this brain is trained, these neural networks that you have in your brain, they are trained. So right now, in these years, we have some data coming from sensors that we have, for example, EEG test. You get the signal from different part of brains. You have fMRI, you have pictures of your brain and other things. So we started a collaboration with a group in Belgium. They get signals of brain when the patient had hallucination, during the time of hallucination or during the time that there is no hallucination, okay? So in two different stages. So we try to get those signals and train a GAN model with different weights and different, structure, saying during hallucination and in normal stage, okay? And we could successfully train two machines, two generators, one for a good person without hallucination, one for somebody who has hallucination, given the EEG signals that we get from the brain. It is just submitted to one of the Nature journals. Hopefully we can get accepted. But this is the first, this is something I really would like to work more and more, because this is a very big question. How these neural networks that we have, God gave us without any, we cannot put price on that. How it is working, still we don't know the answer to that. But now we are in the time that we have enough data, very medical data from our brain, and we have very good knowledge of generative models, how they are working, many types of generative models, diffusion network, autoencoders, GANs, and other things. So probably when we put all these stuff together, we can predict how this element is working in our body, and we can start with visual, then we can go to other sense, hearing, or whatever, the brain is processing all of these things, and this is important to find some answer how this is working. Yeah, this is one of the things that I would like to work on that in this area. Yeah.
Very good, actually very interesting. And for those who are really interested about the topic, again, this type of application are only limited by imagination. So, but if you want to read more about the work of Professor Manshai, the use of generator and discriminator in order for GANs, I think this is a really interesting topic for our students to work on. Now, Professor Amran, you started many startups for AI for Life, very nice name. So I think during your experience both in the industry and academia, you came with many solutions. You mentioned the COVID example, very interesting topic. So can you highlight on one of these applications?
I think, yes, it's hard to pick one, but if I have to pick one, I think the cuff-based diagnostics, the ability to diagnose or screen for disease from the sound or speech in general, starting from the cognitive decline can be picked up from speech to specifically respiratory diseases from cough. I think that is quite impactful, not only because there are 600 million people living with the respiratory disease and it's third leading cause of death, and it's one of the most under researched disease in terms of having biomedical solutions, because we have for cardiovascular, we have for diabetes, a lot of solutions, but we don't have any monitoring or screening solution for respiratory disease. But another impact or possible impact, actually for sure there is going to be impact in moving forward, is the potential to scale it for acoustic epidemiology. The reason, so this is a new field which has emerged in part inspired by that work, is that the idea is that if we go back into the history of mankind for past 1,000 years or more, 90% of the pandemics were respiratory in nature. So, and the reason respiratory diseases become pandemics is because by definition, the airborne spread of the disease leads to faster spread, and that means the cough or the moisture which we emit through breathing, that's the source of the spread of the disease. So if 90% of the pandemics were respiratory, that means in all of them, the sound produced by the lungs is going to carry a signature. So that means if there is ever going to be a system to predict a future outbreak, that probably would involve sound-based diagnostic and capability. Another reason for this to be highly impactful or have a potential for high impact is because sound is one of the biomarkers which we can capture in a very easy way. All you need is a smartphone, and we have sensors everywhere, and then it can be scaled and combined with other biomarkers. So that's, I think, a high impact solution, not only for existing diseases, but also for future pandemic prevention, management, and then you combine it with the mobility prediction, and we have a new kind of epidemic management and pandemic management system.
Very interesting. So we have around 10 minutes remaining in the panel. We'll go through 2 more questions just to be related to the topic. Actually, the need for no, actually, we still have time. So we'll go. We'll probably take one question from Professor Haider now, and we'll come back to the topic. Yes, please, Professor Haider. No, that's fine.
Thank you very much for giving me the chance to ask this question, Dr. Mohammed, Professor Mohammed. I followed your talk and your presentation. Thank you for the presentation. Is there any way, have you ever looked into the possibility of synthesizing your neural network model with any rule-based models for representing the knowledge, especially you were repeating the word knowledge and knowledge and knowledge. So, but just a general question.
Yes, the domain knowledge, the term domain knowledge actually is a more systematic way of representing rules. So symbolic AI, if I understand correctly, you're saying you're talking about symbolic AI. Symbolic AI is an abstract idea where we want to incorporate the rules, the physics of the system. But when we do, the rules can be there in the if and else form, but if you can go beyond the rules, if they can be there in the mathematical form. And then the advantage there is in rules, you can only set boundaries. But when you have a mathematical equation, you can insert dummy variables, and that will lead to higher degrees of freedom. So not only you can shape the boundaries, but also the inner workings of the system as well. So the rules are part of the approach which we are using, but we go one step further by inserting the domain knowledge beyond the boundaries. Yes.
Predicate logic will also help you to insert some dummies. Predicate calculus, predicate logic models.
Yes.
These are also very powerful representation models.
Yes, There's a physics-inspired neural network approach, and that's the idea is that after you have designed the network, you bound its outcomes by the rules. You check its outcome against the rule or knowledge base. Yes, but our approach is that before you design the network design should come from your system's intuitive understanding. So that's the difference.
Very good question, thank you. Now, the last two rounds of question will focus mainly on the topic and the need for flexibility, adaptivity, and proactivity. Let's, for the first question, anyone is free to answer the question. What do you think, in terms of flexibility and adaptivity, why is it needed? I mean, or if you can give like a scenario where you developed an application and it's the case. I mean, things change on a very, very fast pace. You developed an application, it's working only for a specific scenario. For example, you design a network for a stadium. If the stadium is empty, certainly you don't need that connectivity, but if there is 60,000 people, you need to change accordingly. So feel free, please, anyone to answer about the need for flexibility and adaptivity in developed IoT application or banking application or any type of application you develop.
I'll go with this and then others can chip in. So in terms of banking, right, what is the single threat to the customer? The fraud happening on the bank, right, and somebody hacking into things. So there's a constant monitoring of attempts for the hacking. It's easy to identify the certain patterns, right? You have a DDoS attack, etc. These things are easy, right? But how do you identify the exceptions to be able to manage, right? To keep it flexible. For example, right, a particular merchant might have been compromised, right? A particular merchant might have skimmed the cards and is using. How can I detect real time saying that, look, there are 3 cards which from the same merchant which seem to be compromised, which means that I need to block that merchant. So it is about predicting as to what all can affect and be able to have a solution that will meet. Obviously, there will be scenarios that you have not thought about, but that is a very good use case of having an adaptive solution so that you can prevent the frauds happening.
Perfect. Yeah. Professor Filani.
So I can mention another example which is related to the topic of IoT. So as mentioned yesterday, I think during one of the panel, sometimes you have use case where you need to retrain your AI model on the back end, collect a lot of data, like the example of Tesla, collect a lot of data and then retrain the model in the back end and push their update to autonomous vehicles, right? Which is the basic use case. But there are another category of use case and application where you need to run your AI model on the edge side, on the gateway, right? Because of sensitive data, you cannot really send the video streams through the network, or because of the limitation of the connectivity, or because really you don't need that video, you just need the metadata, right? Which is being processed by the AI model on the edge side, right? So where flexibility and plays a role there is how you are going to really to collect your data, retrain the model, and do the firmware update over there, and make sure that you have your model which is running on the edge can adapt depending on, in our case, for example, we have multiple models for detecting cars, classes, counting them and so on, but we take, given these models, computer vision models are very sensitive to the light, to the size of the shapes and so on, so we have multiple versions, and we have sensors to detect weather conditions and everything that they can adapt automatically to use the right model, right time to detect the right object. So this is one of the use cases where we had to consider the flexibility and adaptability into consideration and make sure that our model is very adaptive and can react with high accuracy.
Very good and very interesting. Yeah, so that point of flexibility and adaptivity is very important, but what is even more important than that is to be proactive. And being proactive changes the system from being descriptive to prescriptive. For example, I'm noticing that one of my child is getting addicted to a phone. If I leave him, without taking an action, probably he will or she will end up being addicted. This is just one example. For example, for Mr. Nibhanupudi, it's the example of the banking. They discovered that there are fraud happening to the customer. But what if we detect the fraud before it happens? The same for hallucination, cancer, the network, for example. We don't need to wait for the network to fail and then take an action, okay? And the same also for the example of the World Cup. If you see that, for example, this parking is getting 80%, you don't wait to go to 100% and then start redirecting the traffic. So that brings my next question and the last part of the panel discussion about proactivity. So proactivity is very important. Again, feel free to anyone to answer the question. How do you account for proactive IoT solutions or solutions in general?
Okay, so in some, of course, proactivity is good to have in most domains, but in some cases, that's the necessity. For example, in pandemic prevention, you want to be proactive. You don't want the outbreak to become an epidemic, to become a pandemic, and then start the prevention. That would be too late. So in this case, the proactive screening is required and would be part of the fundamental design. But proactivity actually has a flip side, which leads to high false positive rate and requires continuous screening. So that's a challenge to achieve proactivity, and this is where balance in terms of agility and flexibility and using a low cost or low resource solution. So proactivity can only be achieved if your solution is flexible, lean, and agile. So this is how, all connected together. Yeah.
We have room for one. If you have any other.
Just maybe for the last comment. I was always thinking why we don't change lots of applications that we are using every day, many times, related to banking, for example. Still we are using this card and then scan it, sometimes PIN code and other things, but we know that lots of things have been changed so far. For example, I'm sure that probably in these areas, also in these airports, I didn't try, but in the United States right now, when you want to board the plane, they don't check your, in most of the international flights, they don't check your boarding pass. You just look to the camera and then it shows your seat number, welcome on board, that's it. No passport, no boarding pass, nothing. And I'm probably in Gulf area also it's the same thing. So I'm wondering why we don't go out of the box and remove lots of applications that we are using every day right now. For example, why instead of having these devices that scan the card to pay for Visa or MasterCard and other things, we just develop some application over mobile phone, and then the guy showed the mobile phone to me saying that, okay, I'm Hussein, I want to pay $10 to this guy, that's it. No card, more secure, and we have database for that. So I'm thinking about this revolution on the application given the AI that we have, but apparently there is, still they resist to such kind of huge change in our daily life. And I hope in future we see such kind of application.
That's probably will open also the room for cybercrime. Yesterday we had a very interesting discussion with IEEE. The third largest GPD in the world after US and China is cybercrime. So number 3. So probably that's another discussion on cybersecurity. Yes, please.
If you don't mind, I just want to respond to Professor Mohammed. Obviously, there are digital wallets. So actually, I don't take my card out anywhere. In Kuwait, I just use my mobile.
Yeah, I told that there are, but there is still there are these devices.
Absolutely. But I think in banking, there's one point that is very critical, which the regulators are very particular about. Finally, all of us work for money. You want the money to be safe. the safety and security becomes paramount. So which means that any compromise that people can do, you create something called multi-factor authentication, right? You show your face, but you still want to input the PIN because what if? So you're trying to protect the customer. That's why sometimes it looks, some of these processes look really cumbersome, but obviously banking is also migrating more and more highly technical, but sometimes you find these things, right? Always to protect your money, Professor Mohammed.
Thank you. Very good. So we don't have time for more questions, but we have our keynotes and panelists here available if you have further questions. Just to close, basically the take-off of this panel is really we need collaboration between different stakeholders. All of these topics you see, there are multidisciplinary areas, bright researchers working on healthcare application, banking, and what I will say as a conclusion, there is a strong mathematical background behind this work. I mean, all of our speakers have very strong mathematical background. So please, when you try, especially for our students, if we really want to make a big contribution to AI, Gen AI, and we need to have solid tools that we can use in order to contribute and to successfully deliver. So please, big round of applause for our amazing panelists.
Thank you very much, and now it's time for the award token of appreciation for the panelists. I would like to call Dr. Tribalsi to please hand over the award to them. Dr. Ziad, yeah, please. It's okay. It's okay. I will. It's okay. Okay, thank you very much. Now it's time for a tea break. We will come back at 11 a.m. Thank you. 11 a.m. 11 a.m. Yes. We will resume at 11 a.m.
directly linked computations with the physical world. We've been hearing a lot about the embedded system, but when it comes to communicate in real time with the communication network, that will actually start to be called a cyber physical system. The facts of introducing CPS in the research deliver a continuous evolution of system, integrate with the cross domains, and autonomy of the system, and the main application of cyber physical system is, in our case, energy systems, for example, smart grids, smart transportation, industrial automation, and intelligent medical. So let me take you through the research methodology. So we are aiming to design a cooling and a heating device so that we can connect it with a building simulation software. In our case will be ESPR. So basically ESPR is nothing but a building simulation model, just like Energy Plus or Design Builder. And the reason why I'm using ESPR here is that just because it's based in our university at Strathclyde. So the cooling system device can be presented by the green box. This is a real world system, like for example, in Kuwaiti scenario would be the air conditioner. It actually supplies physical flow and reserve a physical return at the same time. And temperature, you can see the T label, monitor both outgoing and returning temperatures. The digital physical interface, and this is quite complex way of dealing with it, because it actually required a real-time communication bridge between the real physical system and the simulated platform, in our case ESPR, as I have mentioned earlier. It will actually convert physical signals into digital signals and vice versa. For example, here temperature readings and commands from the digital controller would be actually sent back. The simulation system, which is labeled by the yellow box, which is a virtual representation of the environment, and in our case would be the building or a room or a thermal, basically thermal zone. It will actually have the digital flow and return signals and simulates how the space would actually respond to the physical cooling. And basically the last bit, it would be two modeling techniques will actually feed the simulation by dealing with a physics-based model, which is thermodynamic model, and network model, which is using AI-driven prediction based on data we will get. So let's talk about the case study. The Kuwaiti actually grid has actually has the first time in history load shedding aimed in, and just that just because of the high electricity demand we had. So the government, the Ministry of Electricity and Water and Renewable Energy, has scheduled a 2-hour cutting during the hottest parts of the day, and that has actually caused a lot of problems. A timetable, but they don't have any other solution because they need to balance between the demand and supply at the same time. But that has actually caused a lot of problems. These steps are designed to prevent grid overload and manage energy resources. So in 2024, the load has, the peak summer load is about 17,640 megawatt, but the prediction that has actually been predicted by the Ministry of Electricity and Water said that they're going to be an increasement of about 1,000 megawatt, which will make this year, 2025, peak summer will actually reach 18,569 megawatt, which is quite problematic. So let me take you through the model that I have built by using ESPR. In this case, we had the main model input of buildings type in Kuwait, starting from the external wall U value, window construction, zone infiltration, and ending with the occupancy density. We rely on collecting a validated model by Dr. Ali Al-Ajmi from the BAIT, and we got that from the literature review as well, to make sure that we build our model in an accurate way. So this is basically, I don't know why the slide is showing like that, but yeah, this is actually the average temperature and humidity levels in Kuwait. The average temperature goes from 48. It can actually achieve even more than 50 sometime, but yeah, and this is the ESPR model that integrated in the by the Kuwaiti Villa, basically. So let's talk about the results, the thermal comfort and cooling energy load by using ESPR. You can see that the indoor temperature and relative humidity in 2 hours cutting. So we have actually set our set point for like 21 degree, and that has actually, once the power has been shut down, the temperature has rise dramatically to reach about 32, which is quite significantly warm. But if you can see, the main concern is that the cooling energy load for 2 hours cutting has actually dramatically dropped for that 2 hours. But the spark here is that once the power put back basically, or on, the power demand of that cooling has actually reached 10.2. So the question here is that it is quite significant when you actually drop the load for 2 hours and then put it back. That will actually make another peak, and that can be actually answered by this, just because all the equipment, all the air conditioning, all the equipment inside the building will actually work together to reach back, to work even harder again to make the load or the set point temperature inside the room. So that's another issue here. The thermal comfort is bad, and also the load has actually worked even harder, making another peak once the load has been put in the surface again. So what I'm trying to show here is that the end energy use for cooling, by making the set point for 21, will actually have the energy use annually for about 138 kilowatt per hour. But if we increase our set point, and instead of 21, we make it 24, that would reduce the consumption without cutting. That would actually reduce the consumption by 14.4. And that's actually goes back to the announcement we got from the Ministry of Electricity and Water by telling us, please put or make the set point to 24. And instead of making it 21, which will consume a lot. So that's emphasize the announcement of the Ministry of Electricity and Water. And you can see that keeping the set point for 21 and cutting for 2 hours, people will think that will actually reduce the consumption. But in fact, the consumption of the building only has reduced to 2.5. So if we make our set point 24, we will get a better consumption reduction. But if we make it 21 and cut for 2 hours, that will actually reduce it to only 2.5. Now, the other concern, as I have mentioned before, is the thermal comfort. You can see that the PMV, which is a thermal comfort scale-based, has actually reached 1.88, which shows that there is a warm discomfort category, meaning occupants may feel significantly warm, potentially reducing comfort and satisfaction. So let me take you through the comprehensive CPES that I'm actually planning to implement in our lab. You can see that the ESPR model is done so far. It has been validated as well, but there is another step in terms of the ESPR model which need to be done, which is reducing the order model to make it more easy for adaptability with using the FMI. So basically, functional mockup interface is an open standard design for model exchange. So basically, you have two different softwares. You can actually co-simulate between them, exchange the data between them by using this great tool which is called FMI. And then you can see this fully called an emulation system, which is done by using the software, which is called a digital flow of data integration by using FMU. So the Modelica library here, in our case, would be the AC. What I'm planning to do is that I just want to make this emulation system where I can test various of different scenarios. For example, integration of renewable energy through using this Modelica, and then integrated in a real time with the ESPR as a software. So let me conclude by talking about the challenges, future direction in Kuwaiti Vision 2023 alignment. So the main challenge here is that we live in a harsh climate, high cooling demand, which means that there will be a lot of strains in the energy infrastructure, limited retrofit implementation, which actually deep energy retrofit are quite costly and slow, data availability and integration, lack of real time, collaboration collaboration gaps between the government, academia, and industry, digital readiness of load adoption of IoT. Even the future direction is quite important here because there must be a smart retrofit progress and policy changes and making some labs where we can actually test the cyber physical system in a bigger scale. The capacity of the building trained professional are actually rising for showing the potential of the CPES. Thank you so much.
Okay, thank you so much. And if there is any question from Abdurrahman, he is here.
There is one in the back.
All right, thank you for the nice presentation. Actually, as a guy interested in the power solutions and power engineering, I would like to ask, how did you represent the cutoff or the blackout in the ESPR simulation?
Yes. So basically what we have done is that we got the geometry of the building, and then there is some interfaces in the ESPR where you just basically put the occupancy behavior and all the input data of what you have. For example, the model dimensions, the U value you have, and then there is a cutting procedure for the timing. So that basically it depends on the occupancy of what you have, and then during the day you just choose the certain time that you want to cut through, and then you just put no power. That's basically what I have done to investigate what we have got in our last summer peak summer into 2024, to just basically use that as a guideline for myself to further study what I can put as a solution. Yeah. Sorry. What was the peak load? Yeah, the peak load was 17,600 something megawatt. So this is the peak load. So this is in 2024. The peak load was 17,640 megawatt, and basically for next summer, which is 2025, the Ministry of Electricity and Water, they predict that it's going to be increased about 1,000 megawatts, so it will be 18,569.
Okay, thank you, Engineer Abdurrahman, for the nice presentation. So maybe it's my bad because I missed some parts of your presentation. Maybe you mentioned it. But I know that in Europe, the average consumption for, typical house is like around 2,000 kilowatt hour per year. And do you have any statistics here in Kuwait? What is the average consumption?
Yes, basically what I have done is I neglected all the other equipments in the building. What I focused on is the cooling, because let's be clear that the cooling consumption in Kuwait, the main consumption in Kuwait goes 76% for only cooling. So that's why I have actually neglected all the other equipment inside the house, because in fact there is like even 80% of the consumption of the building in Kuwait goes for the ACs.
Okay. Thank you so much.
worries.
Thank you.
Thank you so much, Abdurrahman. Thank you. Okay. So let's go with the second presentation, which is by Mariam Tahir and her group, and it's related to metaverse-driven application. So let's welcome them to the stage.
Hello everyone, I'm Mariam Tahir and my colleague Tala. We are going to present the research paper, Metaverse-Driven Immersive Therapy Reducing Air Travel Anxiety for Individuals with Autism. The research authors, Dr. Ismail Radawi, Mariam Tahir, Tala Hamouri, Shuruk Khan, Fatma Qattan. Today's presentation will cover introduction, proposed framework, implementation and evaluation, finally conclusion. Aerophobia is a strong fear of flying that affects many people. The children with autism and social anxiety, flying is even harder. The crowded spaces, loud noises, and social interactions at airplane can be overwhelming. This leads families to avoid air travel completely, which limits their chance to attend school activities, social events, and family gathering. Our solution involves using virtual reality. Virtual reality is a valuable tool for therapy, especially for children with autism. Using metaverse-driven VR helps children to practice air travel scenarios to reduce their stress. The system tracks user behavior to understand how the child reacts in the environment. Deep learning controls VR avatar to understand how the child control VR avatar, creating a more personalized and realistic experience. The outcome, the virtual airplane app made for Oculus VR headset, helps children with ASD and social anxiety practice air travel step by step, like boarding, finding seats, talking to the flight attendants. It was built using Unity Hub 3D Max and C# and offers a realistic and safe environment. Early test shows good results in user experience and performance. And now, with the proposed framework. The proposed metaverse-driven immersive therapy framework is designed to aid children with autism and social anxiety in preparing themselves for travel by air. The VR environment simulates realistic boarding seats and interactions during air travel. These experiences are made available to users through a VR environment that include VR headset, controller, and other optional components like camera, poster, sensor, smartwatch, and microphone. The VR system is developed by VR tools that include Unity Hub for designing and animating scenarios, C# programming language for coding operational features, and 3D Max for realistic 3D model creation like airplane interiors and interactive elements. These tools work together to handle user interactions and create a fully immersive experience. The behavioral model explains the VR user's behavior through verbal and non-verbal features. Some ASD children express their emotions verbally, while others express them through non-verbal actions. The speech engine enables continuous speech recognition and speech synthesis. Certain words are captured to understand how the user reacts and feel about an event. Non-verbal observation include facial expression, gesture, posture, eye contact, and navigation. Facial expression use features like eyes and mouth to show emotions like fear, sadness, and happiness. Gesture like a thumbs up helps show behavior and feelings. Body posture helps to determine a child's behavior like cramming, which may signal distress. Physiological reactivity capture body changes during stress. Navigating outside the bound set in the VR scenes indicate a lack of interest in the VR environment. Behavioral data is used to adjust the training based on the child's specific needs. The reaction model analyzes a child's behavior to modify the VR environment as needed. The child attitude is based on how they interact with the VR system. The adaptation engine uses visuals, audio, and deep learning to improve the VR experience. Avatar controller controls the user visual representation. VR environment controller changes the visual environment based on user actions, emotions, or reaction. Audio effects use relaxing music or familiar voices to calm the child. Deepfake technique make avatars look like familiar people, like families. And now Tala will complete.
I will talk about implementation and results. In this slide, we started creating the airplane fuselage. We focused on creating a cylindrical fuselage model with properly spaced windows, forming the base for the cabin interior. Next slide shows the design for the 3D characters. We focused on facial geometry with low polyhuman models in a T-pose to simplifying rigging and animation for walking and seating behaviors. This slide shows the 3D design related to the seat of the airplane. On the right, we focused on the seat mesh and the structure. On the left, we finalized the back of the seat with a tray table and pockets, adding realism to the simulation. This slide shows the code related to the user authentication system. It shows how our user login system works. Using C# and Unity, we're creating a secure login system that allows user to log in or continue as guests. If something is login allows user to log in checks that fields are not empty, and if something is missing or incorrect, alerts the user. We also added a profile management system that allows users to update their data. This feature is important to keep user data organized. This slide shows the code related to the glass. When the user moves their VR headset close to the virtual glass, the animation of drinking water plays. It helps users practice simple actions like drinking water on a plane. If they move away, the animation stops. This action is simple, but it's crucial for building routine behaviors in safe and virtual environment. And now I will talk about the results. In this slide, we present the performance comparison between the first version and the latest version of our VR application. As shown in the bar chart, we tested the 3 core functionalities: login success, pick up glass success, and the drink water success. The results clearly demonstrate significant improvement. Login success increased from 70% to 95%, which reflects enhancement in our user authentication system. You can see in the paper we have integrated a more reliable backend API and error handling as shown in the code snippets. Picking up the glass improved from 60 to 90%, and the drinking water success rose from 65 to 92%. These improvements are due to better calibration of screenshots from the paper. The user receives clear visual feedback and guidance throughout the experience, such as the success message after drinking water. These results indicate that our iterative design and development significantly enhanced the user experience and functionality. To conclude, our project offers a new solution for individuals with autism or flight anxiety to overcome their fear of flight travel. Using realistic 3D designs, interactive tasks, and adaptive feedback, they can training in a safe place. It's compatible with Oculus and runs smoothly. We hope to test it in real users and improve it further. Thank you for listening.
Thank you very much. And if you have any question, you can take the authors. We are running out of time, so we'll continue with the next presentation. Okay, so our next presenters are Shahad Al-Shamri, and she will be going to explain about the drone aided. Okay, Dr. Basim will explain.
Assalamu alaikum. Hi everyone, thank you for attending the presentation. I am Basim Halawani. I am with ECE department at KCST. Today I am presenting our paper Drone Aided Agriculture 5, a survey on machine learning and IoT paradigm for smart farming. This work is a collaborative with my brilliant FYP students at ECE department, Shahid, Sarah, Manar, and Raf. The outline of today's presentation is some historical data about agriculture revolutions, essential component of Agriculture 5, type of agricultural drones and their applications, drone payload systems and sensor equipment, and lastly, machine learning application for smart farming and some challenge we will explore. Agriculture has shown a lot of revolution since agriculture 1.0. Was a traditional farming technique with manual labor. Then we have agriculture 2 in the industrial age, where farming machine has been created and organic fertilizer has been used. In agriculture 3, the target was to produce a high yield crop varieties with the invention of irrigation infrastructure and extensive use of synthetic fertilizer and pesticides. Later, we have agriculture 4, where smart farming and digitalization has been created for precision agriculture technique. And finally, we are now going to agriculture 5, which is our target today, where sustainable and AI-driven agriculture with automation, robotic connectivity, and intelligence, of course. What is the essential component of Agriculture 5? Agriculture 5 needs to leverage multiple components to solve a lot of challenges, including, of course, IoT and sensor network for real-time environmental monitoring for the planet, for the soil, for the weather condition, for the irrigation systems. We need a lot of data, and we can collect these data through IoT and sensors. Also, we need to have some sort of automation or robotic platform that can move through the field to do many tasks. Also, we can include drones for many tasks. We will talk more about drone later, for high resolution field monitoring and data collection and doing a lot of tasks. And finally, what we will do with this data, we need a big data and AI and machine learning to take decision and make insight on the process of Agriculture 5. What's our focus in today's presentation? We mainly gave an overview or a survey on 2 topics: the integration of aerial or drone platform for collecting the vast amount of data. Also, we will explore how we process this data through machine learning algorithms for different type of machine learning algorithms to get actionable insights to solve a lot of challenges. First, we need to talk about what type of drones that can be used in agriculture. We mainly have 3 types of drones. The first one is fixed wing drones, which is shown in this figure. We have a lot of prototypes that are working in agriculture field now. This first one, fixed wing drone, require a runway to take off and land. This will allow for longer flight time depending on the type of energy, if it is fuel-based or electrical-based. Also, it has less maneuverability due to the fixed wing structure. This is most suitable for large-scale surveying of agriculture fields. The second one is the multi-rotor drones. We have many types of multi-rotor drones with one rotor drone as helicopter models, or quadrotors, or hexarotors, or different type of drone technology that depend on multi-rotor structures. This has one important advantage over the fixed wing. It can take off and land vertically. Also, it doesn't need any runway to take off or land. Also, it has a high maneuverability and can hover in one position for longer time to make many tasks. Also, it needs less training for operating the drone, different from the fixed wing structure. This will be suitable for smaller or medium-sized agricultural field. The last one combine benefit from both types of drones. It's called fixed wing hyper vertical takeoff and landing drone platform. It has both fixed wing and over this wing we have multiple rotors that allow the drone to hover also, in addition to its possibility to cover longer distance using its fixed wing So it make it adaptive to many situations and many tasks. How can we use drones for agriculture 5? We need to equip the drones with multiple payload system according to the task. The first one is a spraying system. For a spraying system, we can use some sort of tank, pump, nozzles, and flow meters to allow the drone to make a precise application of liquid pesticides or herbicides. Also, we can use a spreading system. This one will be used for dispersal of granule material like fertilizers or even seeding the plants in the soil. It uses some sort of hopper, and both those applications actually need GPS localization for precise spraying or precise spreading of the seeds. The last one is the picking system. The picking system is usually using for harvesting the fruits of the planets, and usually it is combined with some robotics arm or grabbers that collect the harvested or harvest the fruits. But usually it is equipped with some sort of AI technology for selective harvesting for the good fruits or the ones that need to be harvested. Also, we need to collect data. So we need to collect data from the soil. We collect data about the weather. We need to make some images or thermal or humidity of the area. So we need to equip the drone with a lot of sensors. We will explore some of these sensors now. The first one usually is used is the usual RGB camera, which take or capture image in the visible range. It can be used for visual assessment of the planet, for the irrigation, for tracking acid visually. Also, we can have other type of camera in different spectrum, maybe in near infrared spectrum. It can be used for governing or determining the vegetation index of the planet, if it is green or it's yellow. That can be help in determining the health of planets. Also, we have other type of thermal camera or thermal sensors that can detect the variation in the infrared radiations of the planets. It can help in irrigation issues. It can help in determining if the planet is invested by some sort of pest that change the internal temperature of the planets. Also, we can use other different sensors to help the navigation of the robot, like LiDAR, light detection and ranging, which use laser signals to determine the heights of planets, the different topology of the agriculture field that help to create a 3D mapping of for the field to help the plant navigate through it. Also, we need precise localization. All these tasks must be have some sort of precise localization, so we need a global navigation system, GNSS, from any type, maybe global positioning system, GPS, or GLONASS, or Galileo, or PIDO, according to the different type of positioning systems. It can help in programming the flight of the drone to pass, to get some sort of controlled path. Also, we use this for georeferencing. If we detect some plant has some problem, we need to assign some location for this plant on our system for further investigation or for pesticide spraying or any other of tasks that we could do it later. All this information can be integrated in GIS system, geographical information system, for further monitoring and investigation or later use. What we will do about this all data, vast amount of data collected from the drone sensors, from the sensor included in the drone or in the soil or any assets used in the agriculture field. We need to process different type of information like high resolution images, thermal images, temperature, humidity, weather condition, a lot of data we need to process. Previously, it was a problem how to process such amount of data, but different type of machine learning application can process such data now and can identify underlying pattern which can give insights and allow for more applications. For example, we have different type of machine learning algorithms like supervised learning, unsupervised learning, reinforcement learning, and federated learning. And each one of these applications has different type of tasks that be used in agriculture field. For example, we have supervised learning algorithm. We have mainly two types of tasks we can do, the classification and regression. And in supervised learning, we need training data set with labeled data. Some examples of this application is the 3 species classifications. There are many work now that use convolutional neural network, CNN, for automatic classification of 3 species. This will help us to determine what type of tree we are doing with, and every type of tree has certain manipulations different from other types. Also, we can detect harmful plants like weeds. We can use weed detection. There are many works that use algorithms like YOLO and faster RCNN to classify weed and differentiate it from actual plant we want to grow in our field. Also, we can not only determine the type of the tree, but we can determine if it is healthy or not. We can determine crop disease detection using classification algorithms like random forest or support vector machine or CNN or other type of classification technique, supervised classification techniques. Also, we can use regression. For regression, we could use it for yield prediction. We can linear regression algorithm can analyze historical data about the weather, about the planet growth, about the vegetation index, and it can predict what suitable time for the harvesting of planets, how much amount of seeds or harvested plant we can get from this agricultural field. The second one is unsupervised learning. In this type of learning algorithm, we don't need labeled data, and algorithm like crop segmentations, K-mean algorithm can use for crop segmentation. We may have neighboring fields with different type of planets, and we want to detect the boundary of each type of planet, so we can use K-mean clustering algorithm to detect the or to make the crop segmentation. Also, we can detect all type of weeds or unwanted plants that grow inside our field using algorithms like GMM, Gaussian mixture models, to identify outlier within certain area of planets. Third type of machine learning algorithm is reinforcement learning. Reinforcement learning algorithm, we can use different type of algorithm like deep Q network or proximal policy optimization or multi-armed bandit for many tasks related to the control of the drone itself or in its movement, in bus planning, in controlling how much fertilizer or spraying we could do for making some bus planning algorithm or energy efficiency movement or controlling a lot of drones. We may have not only one drone in the field, we may use multiple drones, and we need to coordinate the single task between multiple drones, so we can have a swarm of drones that can be controlled through reinforcement learning algorithms. Lastly, the federated learning algorithm, which is interested in privacy of data. Sometimes we need to train our models in a large amount of data from different farms that owned by different company or different stakeholders, but they are conservative about their data and their privacy. So we need to train small models, small machine learning models in their own data, and we don't share their data actually. We need to share only the gradient or the value of the model itself. In this type of federated learning algorithm, we start by local training in each farm or even on board the drone itself, and we get our small model on their own data set. Then we send the updated model gradients and weights to a server. We don't send the data or images from or about the yield production of any farm. We just send the weights to a centralized server. This server uses different technique for aggregating the weights to create a more general model from many farm, and then send back these models to each farm to get benefit from the training model of each farm alone. This will help in privacy sensitive application or farms that may have competitive agriculture fields. Now we explore some future directions and challenges in the combination of drone technology and AI. We need to have a lightweight AI models to train our models on the drone or in the edge, and we don't send it to a cloud server or something like this. Also, we need to have energy efficient design because drone is must be energy efficient to allow it to fly for longer time. Also, we need a scalable federated learning framework to secure the farm collaborations. Also, in many countries, we need to have some we have some legal constraints, so we need to address these legal constraints that allow or not allow drone to fly in certain areas. Also, we need to solve the problem of high cost of drone technology or machine learning application implementation. And finally, related to communication, we need to send data wirelessly to servers or edge devices. So we need to have efficient communication protocols and must be energy efficient protocols. Finally, I invite you to check our capstone project. It is solve some problem relating to payload system for drone-based technology for agriculture using a payload system of multiple sensor, wireless communication, global positioning system, thermal camera and RGB cameras, and AI model for detecting the palm trees in the field. You can find it in the library, and our brilliant student will be there, inshallah. Thank you.
Thank you very much for this nice presentation. If there is any question from the audience, we have a minute or two. Yeah, quick question.
Thank you very much for the extensive actually coverage of the application of drone to agriculture. You may consider the usage of tethered drones. The tethered drones, let's say if you have building inside the farm, like where the tools are kept, it can fly with the tether.
Yes.
The tether is basically used to power the drone and also for data communication. So this will allow the drone to go for, let's say, forever. It will fly forever because it will have the power coming from. This is one improvement of the energy efficiency.
Yes, actually there are some prototype related to this field. There are some picking systems that connected to a drone, to a robotic platform. Robotic platform is moved in the farm, and it is connected with some sort of tethered wires to power some robotic drones with a picking system in big farm to collect apple or something like this.
Thank you very much, Dr. Basim. Now we can move to the fourth presentation. It is actually by my student, Yusuf Husni, so I would like to call him to the stage to start.
Good morning, everyone. I'd like to welcome every one of you and thank you for attending today's session. So today's paper is, the manuscript is written by me, Yusuf Husni, and my senior professor, Dr. Murad Khan. So to kickstart this paper, this paper talks about machine learning and deep learning, AI. It compares multiple models against a baseline CNN model, integrating and degrading certain architectural parts from the models, and then comparing the results we get
against the baseline model and the corresponding models. So let's start the data dialogue. From the sensor noise to human insight. So what is data? Data is basically whatever we need to extract from the environment to create a meaningful, let's say, a brain simulation. This dataset is simulating a brain basically in a machine learning environment. We gather information and data from wearable sensors and smart environments. The challenge here is how to maintain the high volume and velocity of inherently unstable data and possibly noisy data, because noise is an inherent feature of human activity, and we can't recognize the volatile nature of human activity without eliminating this noise. So the goal here is to extract meaningful patterns from actionable insights on human behavior. So what we're bridging here is a human activity recognition system with advanced AI to address these emerging issues. So what is human activity recognition, HAR? Human activity recognition, as a definition, is a computational method that uses AI, ML, and DL, which are artificial intelligence, machine learning, and deep learning. Each one of these terminologies has a similar meaning, but inherently it has a very slight but very critical difference, which we'll be going over very shortly here. To automatically identify human actions from sensor data, we need an input of time series data, which is the data we're using here, extracted from an accelerometer or a gyroscope. We output classified activity labels from our opportunity dataset, which is the dataset we're using for this particular study here. So the objective of this study is to get a reliable, automated understanding of diverse, complex daily activities on the opportunity dataset. Going over HR applications and hurdles, what are the challenges that face HAR today? So impactful applications that resonates with the world today are healthcare, remote monitoring for elderly people or geriatric homes. That is of utmost paramount importance for these particular segment of the society. No problem. Okay. So the smart environments are a context-aware automation. Like in a smart home, you'd have a lighting system that would automatically go on and off whenever you need without needing to lift a finger or get off the bed. For fitness and wellness, we can get detailed exercise analysis from correlation. This actually exists today in the Apple Watch you have on your wrist. Safety and security, this is actually also very important. So worker safety monitoring, for example, in construction site, for healthier, safer environments of work, the company may use sensors to monitor how the environment in the construction site is going and how safe it is, and to get intrusion detection. So the significant challenges that face HIR today are ultra inherent variability of data and activity complexity, as inherent as it is for human activities, which contain mostly a lot of noise because it's unpredictable and very volatile. And it needs some sort of labeling for the machine learning model to understand these extensively complex patterns. Otherwise, it would be very difficult for the model to extract meaningful patterns. Research objectives, advancing HAR models. So the objective is to develop a more accurate and robust HAR model for complex scenarios, such as moving, for example, a very subtle but important differentiation between walking and running may confuse a model very easily. The approach here we're using is to leverage deep learning strengths of CNNs with attention mechanism, the dynamic focus on relevant signal parts and integrating them into the model allows the models to focus on the most relevant parts of the systems and get the most relevant information out of them instead of just focusing on meaningless patterns. So the evaluation here carries on rigorous testing on opportunity dataset, which is our benchmark dataset, using cross-subject validation. The focus of the study is a comparative analysis of architectural improvements. Sorry. The first architecture, which is the baseline symbol 1D CNN, this is the baseline we're comparing against our 3 other models. So in total, we have on this study 4 models. Starting on with the mechanism, we apply a convolutional neural network that filters across time series windows to learn spatial patterns. The structure of this system carries on a sequential layers, convolution, pooling, and then fully connected. These are the layers of the 1D CNN, the baseline CNN we're comparing against. The limitation of such an approach is ununiform feature processing that is lackluster to the in comparison to the other models we're testing here. So it lacks adaptive focus on critical temporal segmentations. What this means is it's lacking basically the attention model to focus on what's important in the data. The second architecture we're comparing against, which is a step forward from the 1D CNN, is a CNN integrated with attention module. This is a step forward, but also has significant limitations we'll go over in just a moment. The concept of such an approach is an integrated attention mechanism into the CNN feature extraction. The function of such a mechanism is to learn to assign adaptive weights or importance score. These just mean what information on the dataset is more important and what should be focused on through the architecture more thoroughly. The goal is to prioritize silent feature improvement on classification. So, question, what does aided attentional complexity consistently yield benefits? This question is extremely important, and actually our paper addresses this further. So let's carry on, and we'll get back to this. The third architecture is a multi-head CNN. This is different than a deep CNN because a multi-head CNN uses different CNN heads instead of layers. So the concept of such an approach is to employ multiple parallel independent CNN pathways, or AKA heads. The mechanism, each head processes the input data simultaneously with the other heads, potentially learning different feature aspects. So the benefits of this approach is to capture a richer, more diverse set of features by combining outputs of each CNN head correspondingly. So the limitation of this approach is it lacks also a mechanism to weight the importance of combined features. It still lacks a attention module or any module that can extract what is important and assign higher weight values to such mechanisms. So the fourth and final proposed synergy system, which just means harmony. It's a harmonical architecture, combines a multi-head CNN aided with attention module. This addresses the previous concerns of the first 1D CNN and then going over the multi-head CNN and the CNN with attention. The concept of this approach is to fully integrate a multi-head CNN feature extraction with a subsequent attention mechanism. The workflow is, these are just the layers, a parallel CNN head and then feature concatenation, followed by attention layer and then classifies the output. The hypostasis of this proposed harmonical architecture is a superior performance via combined strength for complex HAR tasks. So experimental methodology. we're getting a benchmark data set, which is our main data set, the opportunity data set we've been testing on through the study. We're pre-processing through sliding window technique, 24 steps and 50% overlap standardization. The validation protocol was a cross-subject validation. Inherently, this is very important for generalizability. Architectural compared baseline CNN integrated with attention module and multi-head CNN with no attention, and our proposed system, which is a multi-head CNN. The performance overview. This is just the performance of all of the model combined in one table. The top performer was, of course, our proposed model, which is a multi-head CNN attention module, which achieved a state-of-the-art 99.78% accuracy, and all the other models achieved above 99.7, which is, if you look at it if you look at it on paper, it is very minimal, right? But actually, in reality, this is not the case at all. We'll also get over this in just a moment. So analyzing a single attention anomaly, a single head attention anomaly. So in our single head performance overview, we saw that the single head actually performed a little poorly compared to the baseline model, which didn't have any other mechanism attached to it, and didn't increase the complexity in a way that the other model did. So our observation is that the standard CNN, which achieved 99.75 accuracy, slightly outperformed the supposedly upgraded model of a CNN and attention module combined with it, which in theory must yield better results, but that wasn't the case. And this is not just according to some randomity in the code execution. This was tested multiple times. So it's a counterintuitive results, as adding a single attention mechanism slightly degraded overall performance. Why is that? Because such a minor degradation observed particularly in activities like opening and closing doors in a selected set of features was observed in that supposedly upgraded model. So our implication, attention benefits are context dependent. So context matters. Complexity requires careful integration, and isolated complexity isn't always ideal, and would most likely yield a counterintuitive result. So proposed system against isolated complexity. So our first hypothesis was that the single attention head may struggle to effectively weigh the high-dimensional and complex features of the extracted data by the CNN, the baseline CNN, the 1D CNN. From the full opportunity dataset, which is a huge dataset composing of more than 10,000 features. The second hypothesis is that the potential for the single head to overfit or focus on non-generalizable patterns, meaning meaningless patterns that shouldn't be focused on in such a rich dataset, increases. The second, the multi-head CNN success factor, which is the proposed system, was overlaid of providing a more refined and diverse feature representation before attention is applied. This is extremely important in this case because it applies a harmonical architecture that enables more effective weighting. The core insight of this study is performance against the stems from architectural harmony instead of just isolated complexity. The multi-head CNN with attention not just adds isolated complexity, but adds a harmonical approach to this overall view. The conclusion and future directions for this study could go for a proposed Multi has seen an architecture that achieves state-of-the-art. This is our model, achieves a state-of-the-art of 99.78% on accuracy and F1 score on opportunity dataset via synergic and harmonical integration of these models and the attention design. So our key findings was that a harmonical architecture is paramount in any case. Complexity requires thoughtful integration, not just isolated complexity. Isolated complexity in any case could lead to counterintuitive results. An anomaly insight was that attention mechanisms are not universally beneficial, meaning context matters and context must be always addressed. Feature works could be a deeper anomaly investigation and evaluation on diverse HAR datasets, meaning a different sensor dataset or a different placement methodology. Model optimization for edge deployment, meaning reducing the size and features of the models. So this concludes our today's session. If you have any questions, you may ask. And if you don't, thank you very much for listening.
Is there any question from the audience? Yeah, okay.
Thank you, Yusuf, for the nice presentation. Actually, I would like to ask something. As I tried once to measure the hormones of the human body, do you think that your current project can expand in future to measure also the hormones of the body or not? Like the hormones of dopamine or something like this?
Thank you for your question. This is actually a very important question. Not every architect is suitable for every situation. For instance, human activity recognition machine learning model isn't designed for the same purpose to capture the hormonal activities in a human body. This is purely clinical, so it is needed to integrate a model that can understand these complex, very complex environments of hormones. So you need to carefully integrate a machine learning model that is specifically made and designed for such purposes. So there isn't a universal model that can do everything. Every model has a purpose, and every purpose must be evaluated correspondingly. Thank you very much for your question.
Yeah. Okay, thank you very much. Control and
Afternoon section.
Okay, let's move to the last presenter. We are going to have Farooq Al-Muta. If you are here, please. Okay.
Assalamu alaikum. Let's think that now it's 1 p.m. The sun is blazing. You are waiting for the bus, but instead of sweating in silence, you are in solar-powered fan and AC also, charging your phone and getting a real-time update about your ride. It's not a dream, it's a hybrid bus stop and it's changing everything. Good morning everyone, it's Farham Tawa and I'm honored to present you with my hybrid bus stop in Kuwait. Before I take you to technical details, I'll dive into our points of outline. Firstly, I will talk about the introduction, problem motivation, proposed design, methodology, and achieved goals and future work. I will start with the introduction. I'll present you the hybrid energy harvesting system for sustainable bus stops in Kuwait, optimize power generation based on local environmental conditions, power lighting, and the fans, and also power outlets. I will speak now about the motivation of our project. Because of the Kuwait extreme heat makes waiting a bus stop in Kuwait is unbearable for many commuters. Most exciting stops in Kuwait is lack of shelters and power energy efficient. So our challenge was to redesign this space with sustainability, comfort, and smart services in mind. Now I'll speak about the methodology of our project. Also, and the contribution highlights. What sets our system apart is a multi-source energy harvesting, IoT real-time visibility, and user engagement via mobile app. These contributions go beyond academic interest and industry local time. Also, this one, the system architecture of our project. From our brain of our project is the Arduino R4 Wi-Fi, connect to three relay switches to the fan, LED lighting, also the power outlet. Connect to the solar panels and the battery and the MPPT. We have the 3 current sensors having all details and metrics numbers into your mobile application. So also this one, the block diagram of our project. I will walk you through it quickly. That we have a motion sensor to have once the commuter get inside the bus stop, the LED bulb and the power outlet, both of them will start to automatically. Also, we have the voltage sensor and the current sensor for the power, for the battery and the solar panel to have the metric data and any shortage in the future. So in the flow chart also. And this one I will talk to you about the interface of our system. It's the Blink mobile application. You will get, for the admin, you will get and receive all the data in your mobile application to know if your bus stop is working correctly or any shortage in power. And this one, we didn't forget our commuter to have a mobile application to have all details and book his ride from station to another station, starting from the home page till electronic ticket, and he choose his own seat in the bus. This one, our future work, when we thought about 3 main purpose of our project. To have a future plan, we'll start with them. For now, wind turbine, as in Kuwait weather, most of the time is dusty. So we didn't forget about the solar panel not charging, so we installed a wind turbine. Also, a climate control sensors powered by AI to know any future predictable weather. Also, we installed a piezoelectric flooring to use commuter footsteps and convert it to energy for our bus stop. Thank you for listening. If you have any questions, I will be happy to answer.
Yeah, thank you very much, Farouk. It's great work. I saw your display of the project, very interesting. Now, very good application to make it like higher scale. I think Dr. Ismail knows about this also. In Ottawa, they have devices on each of the bus. So in order to develop your phone app to know the real-time position of the bus, are you considering devices that will be like edge devices on each bus to locate it and have some delay information and so on and so forth?
Yes,
Are you
correctly.
considering this?
Yes, correctly. To have any real life schedules of each bus when the time will arrive, and any late bus will be you will receive data directly.
Very good. Yeah, this is a very good extension of the project if you're considering the scale. And why not we see it in Kuwait? So we count on you to...
Inshallah,
to,
hopefully.
Not a lot of people use the bus, but it's very useful.
Inshallah.
Thank you so much.
Thank you very much.
Now I will call upon the stage Dr. Ismail Al-Ridawi to present a token of appreciation to the presenters. So I will start with Abdurrahman Al-Ajmi, who is the first presenter. Abdurrahman is here, okay. Okay, the next, Mariam and her group. All of them? Mariam Tahir. Yeah. Okay, the next presenter, Shahad Al-Shamri. Okay, Basim. Next one is Yusuf. I think Yusuf already left, huh? Okay. And the last one is Farouk Al-Mutawa. Okay, thank you very much, all of you, and Group Auto. Yeah, okay. Thank you very much. And let's have a break, and we will resume after around 1:30. We'll resume back. Yeah. Okay. Okay, so two places. One here, one hall E, right?
No. It's in the same place of yesterday, but everyone to follow Dr. Ziad.
Yeah. Okay, please go with Dr. Ziad to the poster evaluation.
So no need to record. لا لا هو على Hello, Arhina, Vanchaj, and Sakshi. Just confirm that you are online, please. ما في مشكلة احنا نتأخر يمكن 5 دقائق. Your second session.
I had sent extra slides, but it's too late, right?
Yeah.
Just back up. If I have time, I will.
Sure.
So you're presenting from the email directly, like sorry, downloaded from the email?
Yeah, the one you sent.
Done, right? Okay.
Yeah. I think that's fine. You can talk about the change. Sakshi, I saw that you are online. Do you hear us, please?
You have the Indian numbers, I can call them.
Yeah, can you speak? I received yes. Can you use your mic, please? Yeah, because we want to avoid any technical issue during asking questions. What about Arhina? I see that you are online and you are unmuted, so we don't hear you. You are speaking and we don't hear you. She's unmuted. What is the technical stuff? Probably the mic. Can you speak again, please?
Sir, am I audible?
You are very audible, actually. Thank you so much. Arhina speaking. Can you please speak again?
Hello, sir. Am I audible?
Yes. Do you hear us? Audio. Same as system. What about now? Hello.
Hello.
Yes. Do you hear me?
Sir, I can hear you. Am I audible?
Yes. Okay. Excellent. Let me come back. So we have paper 10, 20, 40.
This is the last one, right?
Yeah, the last session will have your paper and Qasim. This is we start at 3, so it's fine. Prashant, can you try your mic, please? Also, Sakshi and Vanjai. Correct me if I'm pronouncing wrong.
Yes, sir. Am I audible?
Yes. So, Prashant, yes?
Yes, sir.
Very good. Vanchaj is here, but we don't hear you. Can you please try?
Good afternoon, sir.
Good afternoon. How are you doing?
Yeah, great, sir.
Thank you for joining.
So we'll start actually in 2-3 minutes, and I'll be sharing my screen. And by the way, please feel free to ask questions. If you have a question or to one of the other presenters, just send in the chat, and we can read your question. Okay. Please confirm if you are seeing the slides in full screen mode.
Yes, sir.
Perfect. Mariam, how are you? Very good. The only student attending the afternoon session. Only important people attend now. Sure. We look for the quality, not the quantity. So we have Dr. Ismail here and the speakers and Mariam. So we have the best representation from the student side. So we'll get started. This is basically the closing session for the event. And the good, when I was reviewing the program together with the program committee, we received very good applications or submissions from the healthcare domain, which is really interesting. So we have a whole session with, actually we have more than the paper on this session. So we divided this into 2 consecutive sessions and also 1 session that is happening now in parallel to this one. So for this session, we'll start with a paper by Dr. Ismail Al-Radhawi, Ali Abbas, and Dr. Hassan Kazan. And the paper is called Detection of Diabetic Macular Edema Using Deep Learning, a Comparative Study. So please join me in welcoming Dr. Ismail.
Thank you very much, Doctor. I was telling Dr. Ziad, I think this is a bad timing right after lunch. No one will be paying attention, and I don't know what I will be talking about as well.
The next conference will be in Ramadan, inshallah.
Maybe I can tell you what I ate if you want to know. Yeah, just this one, right? Yes. All right, so as Dr. Ziad has mentioned, the title of the paper or the presentation will be Detection of Diabetic Macular Edema Using Deep Learning. It's a comparative study. Now, this work is part of a collaboration that is being conducted between us, some of my colleagues here at KCST, myself, as well as from collaborators from the University of Ottawa. So we have a faculty member at the University of Ottawa that is working on the establishment or the development of an e-hospital system, an e-hospital platform, a complete platform that can be deployed into hospitals, into clinics, and so on. So this is part of the initiative. This is what we're doing right now, or what I will be presenting here is basically a tool that has been deployed into the e-hospital platform. So what I will be doing is first, discussing a little bit about the e-hospital platform or project, give you an idea of what is it about, where we're heading in the near future, and what is the objective of this platform, and then I'll go into the tool that has been integrated into this e-hospital platform. I will be discussing the tool in regards to an AI-based diagnostic tool for a DME, which is diabetic macular edema, and then right after me will be Dr. Hassan, who's a collaborator of ours as well here from KCST that is working with us. He will be discussing another tool that has been deployed into the system as well. Then I will move on into the details of the proposed solution, the deployment strategy, and finally some evaluations and results that have been conducted. So the aim of this e-hospital project is to basically enhance healthcare experience right here. So when we say healthcare experience, we're talking more about providing a full-featured online platform that can be used both by health practitioners as well as patients. So when I say an online platform, I'm not talking about the traditional electronic medical records systems or electronic health record systems. I'm talking about more of a platform that provides not only accessibility towards patient-related data, but as well as the support of AI-based diagnostic tools that can help physicians in diagnosing for certain diseases. So such systems are not something simple. We're not talking about a system that can be used right away. We have to make sure that the diagnostic tool, the AI-based diagnostic tool, provides us very accurate results that even exceeds the accuracy levels of physicians, physical physicians in that case. So to do so, we have to take into consideration a few technologies, and I'll be talking about those technologies just in a little bit. But for the time being, this is the aim of the project, is to provide an online platform that has the capability of AI diagnostic tools in order to assist in diagnosing diseases. And it should be personalized for users. And when I say personalized for users, I mean both the doctors, the healthcare providers, as well as the patients. So that means it takes into consideration the way the patient perceives information. So some patients have some scientific background, and hence they may receive information that is more technical. And some patients, on the other hand, do not have those scientific backgrounds, and they need to receive or perceive information in a different way. So this is what I talk about personalized for users, both in terms of visual experience as well as inference experience in that case. So the main project, given that introduction in terms of the online e-hospital platform, the main objectives are as follows: to provide virtual consultations. When I say virtual consultations, I'm not talking about traditional virtual consultations like teleconferencing, where a patient basically calls, or the doctor calls, and this is something that is ongoing. I don't see it here in Kuwait, but this is something that I have experienced in Canada, especially during the days right after COVID, where the interaction between you and the physician is limited. So what happens is that there is a video conferencing call. So if you have an appointment, you can book an appointment online with your physician, and you can video conference with that physician in order to basically see what are your complaints, maybe diagnose for certain symptoms, order certain tests, and so on. But here what I'm talking about is the next generation of virtual consultations. I'm talking about consultation in terms of digital twinning. So you would have a digital twin for the physician, a digital twin for the doctor. That means you are no longer interacting with the actual physical doctor, your physician, your family doctor, but rather you're interacting with the digital twin of your doctor or your physician. And this is not something that is very, very simple. We have to take into consideration many aspects. So the behavior of the doctor, and not only the behavior, but rather in that case, we're also considering the intellectual ability of that particular doctor. So you have to categorize what this doctor, what kind of medical data does that doctor perceive or has in order to deliver to the patient, as well as the doctor's behavior. So if usually, let's say, the doctor interacts mainly towards male patients, then that particular virtual conversation will take place between male to male, for instance, and hence the behavior, the interaction between the physician as well as the patient should be considered from that aspect as well. So when we say virtual consultations, again, we're talking about next generation. Next generation takes into consideration digital twinning, behavioral analysis, and so on. EMR management, this is something that is traditional when we say EMR. So we're talking about electronic medical records, managing electronic medical records, giving accessibility to electronic medical records for both patients and doctors and maybe different clinics as well as laboratories. And finally, making sure that this system is secured. So you should provide that secure communication, whether this is in terms of virtual conversations or even accessibility to the medical records. You must ensure, or even for the patient, patients should not be able to see their entire medical records. They should be able to see certain parts of their medical records that they are allowed. And this takes into consideration, I mean, government policies and so on. We don't want to go to all those details. So again, another objectives of the projects is to not only give access to the electronic medical records, but to also be able, as I said, to create virtual consultations, book for virtual consultation appointments, and communicate with different entities within the healthcare providers. And more importantly is to integrate the diagnostic tools, and those diagnostic tools can be within the laboratories or within the hospitals or clinics. And last but not least, this is very, very important. This is what we're working on right now, which is streamlining the administrative process. So when I say streamlining the administrative process, physicians as well as their assistants spend a lot of time in the administration process. For instance, if you want to write or request a laboratory test to be conducted for a patient of yours, this takes certain processes in order for do it. Even if it's electronic, you have to navigate through, you have to get a request, you have to get that request accepted, and then you have to transfer it to the patient. And then on the way back, whenever the results are available, you have to communicate this information back to the hospital or healthcare provider. The healthcare provider has to analyze the results, and then the results of this analysis is communicated back to the patient. We can cut short this process by digitizing everything and making a more simplified process in the sense that we use generative AI, we use agentic AI, we use other kind of AI-based algorithms and methods in order not to only diagnose for the disease, but also provide an analysis for the result, provide a treatment plan for the patient. So based on the patient's, again, intellectual capabilities, let's say I, as a person, do not know the details of things related to the heart, and I have a certain heart issue, for instance, I would get the result from the laboratory right away that is communicated in the way that I understand. And in order to do that, you have to understand both what the behavior of the patient, you have to understand what the patient is capable of understanding, as well as how to communicate this result. This is an overall view of the e-hospital project. So the technologies that we are using is number one, digital twinning. Digital twinning, for those that are not aware of, it's basically you're creating a replica of things, a replica of the physical objects or assets, a replica of the processes, a replica of the people. So when we say people, we're talking about the doctors, the patients, and other healthcare providers. A replica of the systems and the devices that are used or are being used by those people as well. Another thing is to synchronize, this is important right here, to synchronize adaptively throughout the life cycle of the object. So if there is any change that occurs on that physical object in terms of, let's say, gaining more knowledge, let's say for a physician, the physician has gained more knowledge in this area, then the digital twin of that physician should be synchronized as well. So what we're doing is basically creating a metaverse of people, a metaverse of things, something that can be used for real-time data collection, analysis, and processing. And obviously, deep learning is the core for medical diagnostic tools, and this is something that we will be looking at as well in the next slide. And finally, generative AI and retrieval augmented generation technology is something that will be used in order to retrieve and deliver accurate information that is perceived towards the patient history, towards the patient's capabilities in that case. So as I said, for instance, if the patient has conducted certain tests to test for certain diseases, and you want to communicate that information for the patient, that report that you send back to the patient should take into consideration the patient's history, medical history, as well as the patient's scientific capabilities in terms of comprehending the information that the patient is being receiving. And then from there you can provide different treatment plans and so on. So we're talking about delivering personalized health guidance that is tailored for patient-specific treatment plans. All right, I think that's enough in terms of explaining the, I'm going way behind the time, right? Can you just tell me, like point out if there's, I'm running out of time. So going into today's topic, the presentation topic, which is in regards to diabetic macular edema. What is DME? DME for short. It's basically a condition that is seen in diabetic retinopathy. So we're talking about diabetic patients. Obviously, you know, people with diabetes may experience different symptoms and diseases and so on. One of them is diseases of the eye. And this is what they may, one of the diseases that they may experience is called diabetic retinopathy, and specifically the classification within diabetic retinopathy, it's called diabetic macular edema, DME. So what is it? It basically causes tiny bulges. In scientific terms, it's called, or medical terms, it's called microaneurysms to occur in the eye or in the blood vessels themselves within the eye. So this would cause fluids to leak into the retina, which at the end of the day, which causes swellings to occur within the retina itself. It's considered a very serious eye disease because that can lead to vision loss at the end. That's why people with diabetes usually need to see a doctor from time to time to measure their blood pressure, to measure the quality of their eyes and so on. So in order to avoid the vision loss, obviously, what we need is early detection and, more importantly, precise classifications, because we have different categories within DME itself. So different classifications for DME, from mild all the way to severe and so on. And obviously, once we get this early detection and classification, the early intervention is needed in order to avoid the potential vision loss. So our work focuses on the early detection and precise classification, and this is done with the support of AI tools right here. So obviously, if the DME disease diagnosis goes undetected or uncategorized correctly or improperly categorized, then we have a problem. And this is something, because it's, as I will show you in the next picture just in a second, it's very hard to tell the class of DME. So sometimes it's very hard for an ophthalmologist to see the difference between which class does that patient have. We'll go through this just in a second. So it's very important that it is properly categorized or classified. So today we have different imaging tools that can be used in order to take images of the retina. One of them is called retinal fundus, and the other is called OCT. They're both high quality types of images, but one is considered two-dimensional, the other is considered three-dimensional. We have many, many data sets today for those DME medical images. We have used one that has been collected from India. I will show you the data set, the name of the data set in a second. But obviously the use of those data sets as well as the advances in AI has led to the advancements and evolution in those diagnostic tools. In addition to obviously screening for such diseases, it provides or reduces the burden at the end of the day on clinical resources. If we have those tools that diagnose for those diseases, if we have tools that diagnose for those diseases, then in fact, obviously we're reducing the burden on clinicians, we're providing more of remote access to patients and so on. All right, so what we use, as I said, is we're depending on the use of retinal fundus medical images, and we apply it to CNN in order to learn the relevant features from those medical images. Once, obviously, those features will be passed through the fully connected layers in order to perform the classification tasks, the classifications in terms of the severity of the DME level. What we use is basically a VGG13-based mixture of experts that determines the severity classification of DME, and then this tool has been, or this model has been integrated into the eHospital platform. This is the data set that we're using. So it's called Optos 2019. It has been collected all the way up to 2019, and it contains 3,662 images in total, samples. They have been collected, as I said, from patients in rural India. The data set does have more than that, but this is what has been used in terms, or what has been annotated and labeled. So those images have been categorized and labeled into 5 different categories. We have what we call no DR, so no diabetic retinopathy. It doesn't mean that the patient is healthy. There might be some sort of DME, but it's not at the level that requires intervention yet. Then we have what we call mild DR. So if you look at the image right here, you would see that there is no dots. So if you look at those things here, those are the dots, exudates, that indicate that there is an indication of DME. In here, you can hardly see any DME. So that's why it's classified as no diabetic retinopathy. Then we have mild DR. You can see, it's very hard to see on the projector, but right here you can see a couple of dots that begin to appear. So that indicates that the patient has DME, but it's mild. And then we have moderate DR. You can clearly see the dots as getting bigger. And now we are getting into the severe case next. The severe case is when we have hemorrhage. And here, that means that there is either a blockage of blood or even a leakage of blood into the retina. And finally, the proliferative DR category or classification, in which basically the patient can be considered legally blind in this case. We face some issues in the data set. So one of the issues that we have faced is the imbalancing of the data set. So from the data set, we saw almost half of the images that have been collected are for the no DR category. Then for the moderate, we have 27%. For the mild, 10%. The severe and the proliferate case is basically very minimal. Image sizing was another issue. We have different images, pixel sizes, and this needed to be taken into consideration before we applied it to the different models. I think I can skip this part. I am running out of time. I can go into the models that have been pre-trained. So we used 5 pre-trained models in order to select a model for the backbone, which was at the end VGG13. We considered VGG, ResNet, ResNext, EfficientNet, and ShuffleNet. And then from those models, we built 9 different models by applying transfer learning on the 5 pre-trained models, and they are VGG13 and 16, ResNet 18, 101, ResNext 50, EfficientNet B0, B3, B4, and ShuffleNet. And then we created a hierarchical approach in order to build the 3 experts model. So the first expert was used in order to diagnose the absence of DR. If DR is not absent, then we move on. So it's basically binary classification. If DR is not absent, then we move on to the second expert for the diagnosis of the presence of moderate DR. If there is no moderate DR, that means we move on to the last 3 categories, which is the classification that is used by the third expert to classify either mild, severe, or proliferative. It was deployed into the eHospital system. I'm not going to get into the details of that. We have certain results. I'm not going to go through them. I'm running out of time, so I'll just show the overview of the results. So the best performing base model was VGG13, and based on that, we have built our 3 model of experts. We have seen that there was an improvement of almost 9% in between the baseline VGG3 model and the model of experts that is based on VGG13. I took more than time than what I'm supposed to do. I will wrap it up right here. Please, if you have any questions, feel free to ask me. I think I'm going to be here around all day. And for future work, what we are aiming for is, as I mentioned earlier, is to use generative AI in order to enhance even further the DME diagnosis. But for the time being, we are using generative AI in order to construct a chatbot that can be used for both patients and doctors as well. If you want to take a look at the ongoing project, we have a specific website URL. It's called e-hospital.ca. That's e-hospital.ca. You'll have access to all those tools and so on. But you have to register first, and then we give you access. From there, you'll be able to access all the tools. Yes, go ahead, please. I think you have a question, yeah?
Yes, we have a time, huh? Okay, just thank you for this presentation. And just I have, if you allowed me, 2 questions.
Yes,
One,
go on.
regarding the unbalanced data. How do you solve this problem of imbalance? Did
So
you
we-
use augmented reality?
Yeah, augmentation.
Augmentation?
At the end of the day. So we created more images from
Just for the imbalance, for
Imbalance,
the...
yes.
Okay. How about, I was thinking that the ResNet 50 will generate
no.
the best result, but
Yes.
when I saw that, do you have any explanation regarding to that? or so?
Not really. I did not implement this. I have students of mine that implemented that. So they are master students. So we stopped the project. The aim is not to enhance or provide a better solution than
No.
what is out there. It's just to create those tools and then plug them into the e-hospital system. So I really didn't dig deeper into why VGG13 was the baseline model was the best over the other ones.
Okay, good. Thank you.
All right, thank you.
Very good. Thank you so much. Questions offline. Go to Dr. Ismail's office. Thank you. Thank you so much. Yeah, it's indeed a very nice presentation by Dr. Ismail. So the second paper, Dr. Hassan Kazan, please join us on stage for paper atrial fibrillation and arrhythmia classification using 12 lead ECGs comparing different ML models. Yeah, the title is try to get rid of this.
Good afternoon, everyone. Thanks, Dr. Ismail, for introducing the project. So this presentation is also a, let's say, continuation of what Dr. Ismail started. So it is part of the e-hospital system that we are doing at the University of Ottawa. So my presentation, it is about the atrial fibrillation and arrhythmia classification. So we are doing some benchmark comparing machine learning models. So I'm Dr. Hassan Kazan, and this work was done in collaboration with Dr. Ismail and Dr. Ali Abbas from the University of Ottawa. Let me first start with the... Okay, just a roadmap of what I'm going to talk about today. I will start with a small introduction, the objective of our research, the methodology, the solutions that we got, results, and a small conclusion. So, based on statistics from 2024 from the World Health Federation, the cardiovascular disease is the world's #1 killer. So, based on their statistics, we have almost 21 million deaths every year from this disease. And these deaths, let's say, they form 33% of the global deaths. And more than 75% of these deaths take place in the low and middle income countries. So from the right-hand side, as you can see from this picture, that the CVD, which is the cardiovascular disease, it is number one in the, let's say, in the causes of deaths. Then we have the cancer, and we have many other types of diseases. So also based on a research from the last year, from the, let's say, publication from the Journal of Cardiac Failure, it shows that the number of people with the heart failures, it is gradually increasing in the next coming years. So the cardiac diseases, we have different types of the cardiac or the heart diseases, and these diseases fall into several categories. So we have many types of categories. We have, let's say, the coronary artery disease, the heart rhythm disorders, the structural heart disorder diseases, and many other diseases. These diseases, they are classified based on what part of the heart is affected. So our focus in this research is on the disease category, which is called the heart rhythm disorders. So what does it mean, heart rhythm disorders? So heart rhythm disorders, which I am going to refer to it as arrhythmia in the next coming slides. So when you say you have an arrhythmia, this means your heart beats too fast, too slow, or in an irregular, uneven pattern. So some of these arrhythmias, they are harmless. Some of them, they can cause strokes or cardiac arrests. So, and also these arrhythmias, they are also classified based on which part of the heart and the rate and all these things. Our focus in this research more specifically on the atrial fibrillation, which means it is an irregular and often very rapid heart rhythm. So as you can see from this slide, there are several classifications of the arrhythmia. And our focus in this, so there are several researches and let's say works being done and still ongoing on the different types of the arrhythmia, but in this paper I am focusing only on the atrial fibrillation. So in the next coming slides, I'm going to refer to the atrial fibrillation as AFib. So just because of the lengthy word. Okay. So this is just introduction about the disease we are talking about. Now I am talking about the ways how this disease is detected. So mainly we use, let's say this is in the medical world, so the electrocardiogram. This is which I am going to refer for it as the ECG. This is one of the simplest ways and tests to evaluate the heart. And let's say this tool, it produces some type of waveforms. So in order, let's say, to differentiate between the heart rhythmia disorders and the normal heart, so I am just showing here, for example, for the normal heartbeat, there is a continuous, let's say, interval. So in the, let's say, healthy resting heart, the normal heart, for the normal heart, let's say, it is between 60 to 100 beats, or let's say, beats per minute. While for the heart rhythmia disorder, where we have many types of heart rhythm disorders, we have different type of ECG, let's say, pattern and different frequencies and all these things. So here you can see just a figure showing the difference between all these types of arrhythmias. So our focus here it is only on the atrial fibrillation, and the atrial fibrillation, normally the heartbeat is between 110 and 180 beats per minute. So our objective is to develop a machine learning based solution which can detect and classify heart-related conditions using data collected from different ECGs. So our objective is to help the medical professionals for early diagnosis and for, let's say, the early intervention. So what we did, we used a publicly available dataset, which is called the PTB-XL ECG dataset. And this dataset, it contains more, let's say, almost 6,500 ECG forms for patients. And these, let's say, forms, they are pre-labeled by many cardiologists. 80% of this data, we used it for training purposes, and we used only 20% for the testing. So we classified this data into 3 classes. First, we classified it to, let's say, this data was classified first to normal sinus rhythm, which is NSR, which refers to the patients that they have a normal heart rate or beats, okay, so which indicates people without any indication of irregular heartbeats. Then we have our concern here, which is the AFib, which contains the data for the patients with the ECG data that they have atrial fibrillation, and all the other types of arrhythmia we classified them, or we put them under a topic which is called the various arrhythmias. So we have 3 types of classifications in this, let's say, paper. So in order to understand what we did, so just small introduction of how the things work. So with the heartbeat from the ECG, we see that we have, let's say, a frequency of waves. And each of these waves, it has a pattern, it has, let's say, a special look. And in this wave, it has many landmarks. And these landmarks, so we have, let's say, some points in this interval. So what we are going to do, we need to do some type of measurements. These measurements, they can be time measurements, frequency measurements, or many, let's say, other types of measurements. So what we did, as I already mentioned, we categorized these data into 3 categories. The NSR, which contains almost 2,000 ECGs, the atrial fibrillation, it's almost 1,600 or 587, and the various arrhythmias, they were 2,841 ECGs. So, and we used some tools in order to extract the time domain features and the frequency domain features from these ECGs. So because we need to get some landmarks, so this is how it is going to look like. So we need to let's say, to extract these landmarks from all these ECGs. So as you know, there are many types of machine learning. So as we want to classify the types of diseases, so we had to use the machine learning algorithms, and more specifically, we used the supervised classification algorithms. So there are many examples of the algorithms. So we used 5 classification supervised learning classifiers. These classifiers, they are the XBoost, the random forest, the super vector machine, the key nearest neighbors, and the adaptive boosting. So these models were trained and tested on all the ECGs that I just explained. So in order to evaluate the performance, let's say we used many metrics to evaluate these these algorithms. So we used the accuracy. Accuracy, this means the percentage of the correct predictions, and the precision, the percentage of correct positive predictions out of all the positive predictions made, the recall, and the F1 score, which is the mean of the precision and recall. So we used these evaluation metrics in order to evaluate our 5 models. So based on the evaluations and on these metrics, so we had these results. So as you can see from the chart and from the table, the XGBoost algorithm, let's say it was the best one in detecting and classifying all these types of diseases. So here in the, let's say, with the table, we can see the accuracy for, let's say, the measurement for each of these metrics. And as you can see, that was the XGBoost. It produced, let's say, the highest values in terms of accuracy, in terms of F1 score, precision, recall, and all these, let's say, metrics. Also, we used let's say, the receiver operating characteristics curve in order to compare all the models. And we can see that also based on the classification, the XGBoost was the best, let's say, AI model to be used for classifying all these diseases. Finally, after we found that XBoost is the best one, so we implemented the system. So the system was implemented on the eHospital platform. So the system was built online, and it was based on the XG boost, where we feed it with the ECG metrics, ECG data, and then we implemented the XG boost, which helped the professionals, the medical professionals, to detect the types of diseases. So our conclusion, it was that we developed a machine learning solution for detecting, let's say, mainly the AFib, and we classified the other arrhythmias. We used the XBoost because it performed the best in terms of the accuracy and the F1 score, and we integrated this solution to the e-hospital, which also includes many different models for different classifications of other diseases, and we are planning in the future to incorporate more deep learning and longer ECG recordings for enhanced diagnosis precision. Thanks a lot for listening.
Yeah, thank you very much, Dr. Hassan, for the
Thank
great
you, Dr.
presentation.
Ziad.
It's a really very interesting topic together with the first paper.
Thank you.
We'll open the room for questions.
1 second, no questions, I will leave.
Thanks, doctor, for a nice presentation. My doubt is here, you used 12 lead, right?
Yes,
But
the 12 lead.
Have
Yes.
you tested with a single lead or 2 lead system?
Yes, the students that they are working with, they are doing tests on the single, but the results were not promising results. So yes, they are doing this, yes.
Okay, second thing, your data split is 80-20.
Yes.
That usually give high accuracy, right? So have you tried with a 5-fold cross-validation or other methodology of validating the result?
In fact, I don't know if the students have done this or not, so I really don't have an answer because I am not, let's say, part of the tests and the implementation. So I don't know if they have done this thing. So I'm presenting, in, say, on behalf of them. So I don't know if they really did this thing. Okay, sorry.
I just have one question. No?
Yeah, please.
I just need to ask you if you have performed any normalization or scaling for the
Yes. What the students they did, yes, they did all the scaling of the images. Yes, because we have different types of images. Yes.
Okay.
Thank you.
Yeah, thank you so much. Please, for the ECG, it's really amazing. How did you get this data? It's really interesting.
It is available on my public.
Perfect. Yeah, this is the type of data sets that help people do research. Thank you so much. Okay, so our next paper is online, and we have Arhina Ghost. She's with the Amit University in India. So Arhina, just please, if you confirm again that you are online, because we'll play the video of your presentation, and then please be available for the Q&A session. So can you please...
Yes, sir, I am online, sir.
Perfect, great. So I'll start your recording, and then we'll have you for Q&A. Thank you.
Hello, sir.
Yeah, the recording is starting shortly.
Good morning, everyone. My paper ID is 10, and the title of our research work is Multimodal Pain Recognition, Integrating Facial Expressions and Biomedical Signals with Deep Learning. I am Arhina Ghosh from Amit University, Noida, India. I am the corresponding author of this research work. There are other 4 authors. On behalf of everybody, I am going to present our research work. Starting with the introduction, accurate pain assessment is central to clinical care. However, it's traditionally based on self-reporting, which is inherently subjective and can vary from patient to patient. This variability motivated us to explore objective automated methods. Our solution is to use both facial expression and physiological signals, a multimodal approach to assess pain more reliably. Moving to the motivation and objective. Our main goal was to effectively combine video and biosignal data to detect pain. We used a CNN by LSTM architecture to leverage spatial and temporal dependencies. To make this even more robust, we optimized our feature selection process using particle swarm optimization. We validate this model using well-known matrices like accuracy and F1 score. In related work, several approaches have been proposed over recent years. CNNs, RNNs, and transformers have all contributed to advancement in pain recognition. For instance, models like STGCN and ensemble methods have used video and biosignals with some success. However, issues in data integration and temporal modeling still persist. Recent studies have explored vision transformers and even explainable AI techniques for pain recognition. Despite these efforts, most existing models either focus on a single modality or lack adaptability to real-world conditions. This gap led us to design a hybrid model that more effectively fuses and interprets multimodal data. Our proposed approach overview. Our proposed framework uses a CNN by LSTM model where CNN handles spatial feature extraction from videos and by LSTM captures temporal patterns in the physiological data. Before training, we have applied PSO technique to select the most meaningful features. This multimodal fusion provides a more holistic view of pain recognition. The dataset which we have used is BioVid Heat Pain dataset, a well-established resource for pain research. It includes synchronized video and physiological recordings from 87 healthy subjects exposed to controlled heat stimuli. The labels are clearly marked as pain or no pain, allowing for effective model training and testing. Moving to the pre-processing and feature extraction. Data pre-processing was very essential for our research work. For video, we have used low-pass filtering and calculated temporal derivatives to smooth and track motions. For biosignals, we have used Butterworth filter to reduce noise. Then we have applied early fusion to combine features from all modalities, resulting a comprehensive of 228 feature vector. Moving to the feature selection part, feature selection was handled using particle swarm optimization, inspired by bird flocking behavior. It iteratively improves candidate feature subsets. Out of the 228 features, PSO selected the most relevant 103. These steps significantly boost model efficiency and accuracy. Moving to the next part, that is model architecture. Here's a summary of our architecture. We start with convolutional layers for spatial processing, followed by max pooling. Then come to BILSTM layers, that is bidirectional long short-term memory that model temporal dependencies. Finally, a dense layer and a sigmoid activation function produce the binary pain versus no pain output. For training, we have trained the model on 80% of the data and tested on the remaining 20%. We have used the Adam optimizer with a batch size of 32 over 20 epochs. Evaluation metrics included accuracy, precision, recall, F1 score, and AUC ROC curves to ensure a comprehensive performance assessment. Moving to the result, the model performed very well, achieving over 86% accuracy and an F1 score of more than 91%. The confusion matrix visualizes the model's predictions against the actual outcomes. The top left cell shows that 89% of the pain instances were correctly predicted as pain. The top right cell of the confusion matrix indicates that 10% of the pain instances were incorrectly predicted as no pain. And the bottom left cell shows 30% of the no pain instances were incorrectly predicted as pain, and the remaining 69% of the no pain instances were correctly predicted as no pain. In summary, the model demonstrates a strong ability to correctly classify pain with fewer errors in predicting pain compared to no pain. We can also see the overall performance metrics in the table. The ROC-AUC curve was also particularly strong for the pain class, suggesting excellent class separation. These results outshine existing methods like random forest and RNN-based systems. Moving to the comparison with the state-of-the-art models. This table summarizes the comparison. Our model not only outperformed classical approaches like wavelet, random forest, but also more advanced ones like transformers and RNNs. This confirms that careful integration of multiple data sources paired with optimizations makes a measurable difference. In conclusion, our PSO optimized CNN by LSTM model proves highly effective for multimodal pain recognition. It not only leverages multiple data types but also ensures optimal performance via smart feature selection. It's a significant step toward real-time, reliable clinical tools. Moving to the future work going forward, we aim to address dataset imbalances and experiment with attention mechanisms. We also plan to include more diverse datasets and test other optimization strategies to see if we can further improve accuracy and generalizability. This slide lists a selection of the references that guided our work, including the foundational studies on deep learning, multimodal pain assessment, and bioweight dataset. Thank you for your attention. I am happy to take any questions further.
Yeah, thank you very much, Arhina. So we'll check with our audience if there are any questions.
Yeah,
yes, we have one question.
Yeah, I'm confusing why you are using particle swarm optimization in order to select the features, and what kind of features that you used in general.
Basically, there are multimodal features. Like from videos, we have extracted features like distance between two eyebrows and distance between nose and mouth. And similarly, from physiological signals like GSR, EMG, we have extracted physiological signals that are, and we have combined these two type of features and prepared a multimodal model.
So have you tried to use the with and without particle swarm optimization?
Actually, we have tried one more optimization technique that is genetic algorithm, but we have seen that PSO technique is performing well than the genetic algorithm.
Okay, thank you.
Very good. Yeah, another quick question. So I think you have a question?
Yeah,
Yes, please.
and regarding the comparison, benchmarking, all the earlier works have used the same data set? Slide number
Not
13.
no, sir. Not all the papers are using same data set.
Then how do you compare your performance?
Like they are using some of the papers are using only signals data, and some of the paper have used only the video data.
From the
Like
same
the
data
data
set?
set is same, like BioWit heat pen data set. That data set had two part, like video and signals. Some papers have used only the physiological signals part, and some paper have used only the video part.
Okay, in terms of the performance is concerned, even you give no pain data, your model is detecting pain. There are too much of false positives, right? In the
Yes,
confusion matrix. So what is the reason?
And the reason is class imbalancing. So in future, we have decided to work on that. To handle that class imbalance, we have thought like we can use SMOT technique.
Okay, thank you. Thank you so much.
Very good. Yeah, actually, this is very interesting work to detect the pain using facial. You can also combine with other, probably the heartbeat, or because pain is sometimes it's not easily expressed. So, because like I'm relating this to the previous presentation, exactly, and the pain depends on the age also. So we can like probably an old man is different from a younger, and so on. I don't want to go into a gender difference and the age, but the pain is different. But you can have a supportive kind of external extra data to support. But obviously, this is a great work. Thank you so much, Arhina, and the co-authors. Thank you.
Thank you, sir.
So we'll move to the next presentation. So also the next presentation is recorded, and we have already Van Saj, who is online. Can you please again confirm you can hear us?
Yes, sir, I can.
Thank you so much. So we'll start your recording, and then we'll have the questions, okay? Thank you.
Good afternoon, everyone. We are Vancha Javasti and Prashant Dubey, and we are excited to present our research at the S4IoT25 conference. Our paper ID 20 focuses on Clahe augmented MRI dementia classification via soft voting ensemble with gradient-based analysis and dementia correlation.
In this work, we explore a novel approach to improve the accuracy of dementia classification using MRI scans by combining advanced image enhancement techniques with a robust ensemble of deep learning models. We also delve into the interpretability of our models' decisions and analyze the correlation between different stages of dementia. Moving on to the introduction, dementia presents a significant global health crisis affecting over 55 million individuals worldwide, with nearly 10 million new cases emerging annually.
A key challenge lies in the early detection of dementia. Early stage dementia, such as very mild, mild, and moderate, often exhibit similar structural atrophy in MRI scans, making accurate differentiation quite difficult. This underscores the urgent need for improved diagnostic methods beyond traditional neurophysiological tests and manual assessments, which can be subjective and variable. Building upon existing research, several recent studies have highlighted the potential and limitations of machine learning in dementia classification. Elethrani et al. Developed an expandable machine learning model but noted the need for better generalizability. Diago et al. Built effective classifiers for early Alzheimer's using MRI data, emphasizing the need for real-world validation.
Furthermore, Alsube et al. Review of deep learning for Alzheimer's disease detection identified challenges in data interpretability and generalizability. Similarly, Dara et al.'s survey on Alzheimer's diagnosis using neuroimaging pointed out issues with multimodal data, incomplete data, overfitting, and interpretability. Our work aims to address some of these persistence challenges.
Our primary research objective is to achieve an enhanced feature representation for reliable dementia classification. We aim to leverage the strength of both CNNs and transformers to capture detailed local features and broader global context from MRI scans, ultimately improving feature extraction.
Secondly, we focus on improved generalization. Our ensemble approach combined with our pre-processing pipeline is designed to enhance the model's ability to generalize on unseen data and reduce overfitting. Finally, we aim for increased interpretability by using GradCam and attention maps to visualize the model's decision-making process.
Our methodology begins with a detailed pre-processing pipeline applied to the MRI scans to enhance image quality before feeding them into our model.
The pre-processed data then goes into our hybrid ensemble model, which combines CNN-based architectures like ResNet50, ConvNext, and DenseNet121 with transformer-based models such as Swim Transformer and Vision Transformer. The predictions from these individual models are combined using a soft voting mechanism. Finally, the model's performance is evaluated using various metrics and its interpretability is assessed through GradCam and attention maps. For our study, we utilized the ADNI dataset, which comprises a substantial collection of approximately 87,000 MRI scans. From this, a split of 8,500 MRI images was specifically used to evaluate our models.
Before feeding the data into our models, we applied a comprehensive pre-processing pipeline. Key steps in this pipeline included N4 bias field correction to reduce intensity inhomogeneities, contrast limited adaptive histogram equalization or CLAE to enhance local contrast, denoising to remove noise artifacts, Sobel edge detection to highlight structural boundaries, Otsu's thresholding for image segmentation, and K-mean segmentation to further refine tissue separation. This pre-processing stage is crucial as it ensures better image quality and improves the quality of feature representation for reliable dementia classification. Our model architecture employs a hybrid ensemble strategy combining the strengths of both convolutional neural networks and transformer networks. Specifically, we utilized CNN-based models including ResNet50, ConvNext, and DenseNet121, alongside transformer-based models like Swim Transformer and Vision Transformer or VIT.
The rationale behind this selection is that CNNs excel at extracting intricate spatial features from the MRI images, capturing local details crucial for identifying subtle abnormalities. Complementing this, Swim Transformers and VIT are adept at capturing broader and global contextual information within the images, allowing the model to understand the overall structural relationship. For training, we used cross entropy loss for multi-class classification and Adam W optimizer with specific learning rate and weight decay. We also employed automatic mixed precision, which is AMP, for efficient training. Our results highlight the strong performance of the Swim Transformer model, which achieved particularly high AUC ROC scores of 0.99 for mild dementia and 0.97 for moderate dementia, indicating its effectiveness in distinguishing these early stages.
Overall, our ensemble model achieved a Cohen's kappa score of 0.57, demonstrating a substantial level of agreement between the predicted and actual classifications. Additionally, the Matthews correlation coefficient of 0.60 further indicates a good correlation in our model's predictions, while maintaining an average overfitting ratio of 0.24, suggesting a reasonable balance between performance and generalization. To further understand the relationships between different dementia stages, we performed TSNE visualization. As you can see in the TSNE plot, there is a noticeable separation between non-demented cases and progressive stages of dementia. Interestingly, we also observed some proximity between data points of very mild and mild dementia, suggesting a degree of feature similarity in these early stages of disease.
Complementing this, our correlation analysis, specifically focusing on the Swim Transformers feature embeddings, reveals strong positive correlations between non-demented, very mild dementia, and mild dementia categories. These indicates that swim transformer is particularly sensitive to the subtle changes occurring in the transition from a healthy state to the initial stages of a dementia progression, highlighting its potential for early detection.
To understand what our model is seeing when making predictions, we employed interpretability methods. Specifically, we use GradCam and attention maps to visualize the crucial regions within the MRI scans that most influence the model's classification decisions. The top row shows attention maps generated using the convext model, highlighting areas it focused on. The bottom row illustrates GradCam applied to the swim transformer, overlaying a heat map onto the original MRI image to indicate the regions of highest importance for prediction.
These interpretability techniques provide valuable insights for clinicians by highlighting the specific brain areas that our model identifies as most relevant for dementia diagnosis. This can be potentially aid in understanding the pathological changes associated with the disease. While our findings are encouraging, it's important to acknowledge the limitations of our current study. Firstly, our analysis is based solely on MRI data incorporating multimodal data such as PET scans or clinical notes could potentially provide a more comprehensive view and further improve the accuracy of dementia classification.
Secondly, the generalizability of our model might be limited by potential biases inherent in the ADNI dataset we utilized. Additionally, our ensemble model currently employs an equal weighted voting strategy, exploring performance weighted voting methods, where the contribution of each model is determined by its individual performance, might yield even better results. Finally, the scalability of deep learning models and their high rating training resource can pose challenges for real world clinical deployment. Our study yields several key findings. Firstly, our hybrid ensemble model demonstrates superior feature extraction capabilities, capturing both local and global MRI features more comprehensively compared to individual models.
Secondly, the detailed pre-processing pipeline significantly enhances the quality of MRI images. Furthermore, the ensemble model provides a balanced and robust classification performance across all stages of dementia. Notably, the swim transformer exhibits particular strength in accurately classifying mild and moderate dementia stages. Finally, the integration of GradCam and attention maps improves the model's interpretability.
Looking ahead, we have several directions for future research. We plan to explore self-supervised learning techniques to leverage unlabeled data for improved feature learning and investigate domain adaptation methods to enhance the robustness of our model across different MRI scanners and protocols.
We also aim to delve into causal inference to move beyond correlations and gain a deeper understanding of the underlying factors driving dementia progression. Furthermore, we intend to incorporate multimodal data such as PET scans, genetics, and cognitive assessments for a more comprehensive analysis. Finally, a critical aspect of our future work involves addressing the practical challenges of clinical deployment, including scalability, computational needs, and seamless system integration for real world clinical use. This slide presents a list of references that informed our research. These publications provide the foundational knowledge and context for our work in dementia classification using machine learning and neuroimaging.
We have drawn upon a range of studies to develop our methodology and interpret our findings. We would be happy to elaborate on any of these references if you have any specific questions. At this point, we are open to any questions.
So thank you very much, Vansaj, and we'll open the room for one or two questions. So we have one question here.
Hi, thank you for this nice presentation. I just have a question regarding the your accuracy in terms of testing accuracy was very low. So I think it was 63 out of 100. While your accuracy or the validation accuracy was around 93, I think. Could you please tell me what is the reason of this?
Yeah, thank you for the question, sir.
This one, yeah. 68
our
while
testing
it's
accuracy was very low
99.
because of our dataset variability. Our MRI dataset from ADNI had patient anatomy dataset, while disease presentation was very low in that. Also, because of class imbalance, the validation accuracy was great, but we handled different dementia stages well in validation stage, but we were not going well in testing accuracy. Also, the subtle differences in early stages, like mild cognitive impairment, mild dementia, and no dementia, were not going well in testing accuracy because images were somewhat same in MRI scenario.
But yeah, from my point of view, I think it's due to the overfitting of the system or to the kind of the splitting data for training and testing. Maybe you select the best data for training while the worst data for testing the system. What about the size? The size of
Yeah,
training and testing?
So the question, what about the size of the training and testing?
yeah. So size of our training and testing were like we divided the data set into 70, 10, and 20. 70% was for training and 20% was for testing, while 10% remains for validation.
So randomly select or manual?
Yes, sir, it was randomly.
Okay, thank you.
Okay, very good. So we have a second question.
Yeah, good afternoon. And what is the purpose of combining all the complex model together to perform a soft voting? Because all the deep learning model what you used all are time consuming and highly complex. So what is the purpose of combining all this method, deep learning models into for a simple classification?
Uh, Thank you for the question, sir. The primary purpose for combining all these complex models were through soft voting was to leverage their complex strengths and to create a more robust and accurate classification system. Since using single model, we were not able to achieve that high accuracy. Also, like for different features, we use different models like CNN, ResNet 50, and ConNext were used for strong features for capturing local spatial hierarchies, while transformers like Swim Transformer and VIT, Virtual Transformer, were used for capturing long range dependencies. So, by combining different complex models, we were targeting different features to maintain high accuracy.
Okay. So
Yeah, that's a very good point. Because when it comes to selecting the best combination, you need to know, if I may say, the mathematics of the data. Why, for example, one of the keynote speakers mentioned that you use Professor Filali. He mentioned about using LSTM because it have time series data. So the combination, although some people they do it randomly or just testing trial and error, I think it's very important to have at least an understanding why we combine such techniques. Any follow up on this?
But one of because why I asked you, the data set is not huge. It is not a huge data set. For this moderate or smaller size data set, by using this type of high-end model, it increases the computational complexity. So performance of accuracy is not only the only objective. At the same time, the reliability, how fast we get the accuracy, right? Okay, and again, MCC, the value of Matthews correlation coefficient is very low. It shows that your model is not efficient in deducting or classifying the images, right?
Yes, sir. So, like for this, we had 4 different classes, and our main challenge was multi-class classification. Our task was divided into different dementia stages: mild, non, very mild, and high dementia. So we used class imbalance also, class imbalance handling also. So that's why MCCs are sensitive to class imbalance. So our score was low.
Okay. Okay,
Very
thank
good.
you.
I think these are very good feedback. Again, to summarize, these are important things that probably can be taken into consideration. You need to consider the price you pay when you do such combination because the complexity increase, so you lose in terms of performance or reliability. And the last point is the correlation. So I think this is what's best. The best part of presenting the work is to get such feedback for further improvement. But indeed, it was a great work, and thank you again.
Thank you, sir.
So for the session, because we have another session after a short break, but we have our last presentation of the paper now. And this is by, no, not Professor Murugapan, that's afterwards, Professor Murugapan. So we have Richi, Manipal, Garima, Amity paper, and also Fansaj, who just presented, but this paper will be presented by Sakshi. Just again confirming that Sakshi is with us online.
Yes, sir.
Perfect, thank you so much. So we'll start your presentation and then again we'll finish with the Q&A. This is control.
Wireless power systems for implantable medical devices with a focus on enhancing efficiency and precision in Parkinson's disease neurostimulation.
Our research addresses the critical need for improved power delivery to these devices. Our presentation will cover the key aspects of our system from its design and validation to its potential impact on Parkinson's therapy.
We are Pankaj Avasthi and Sakshi Nipane, and our paper ID is 40. Parkinson's disease is a progressive neurological disorder affecting over 10 million people worldwide, significantly impairing motor function. Deep brain stimulation is a widely adopted treatment that uses implantable devices to deliver targeted electrical stimulation.
However, current DBS systems rely on batteries requiring frequent surgical replacements. These procedures increase healthcare costs and pose a recurring risk to patients. Our research introduces an AI optimized wireless power transfer system to address these limitations, offering a more scalable and patient centric alternative.
Our work builds upon existing research. Han et al. In 2020 analyzed thermal risk in WPT devices, advocating for phase change materials (PCMs) and nanomaterials, approaches we have adopted in our thermal design to maintain a tissue temperature rise of less than 1.5 degrees Celsius.
Zhang et al. In 2021 demonstrated AI-based tuning improved WPT efficiency under dynamic conditions, which is reflected in our 15% AI-optimized gain. Al-Khatani et al. In 2021 highlighted the limitations of battery-based DBS, promoting wireless alternatives, a core focus of our solution.
Our system architecture comprises several key components. The transmitter uses adaptive antenna arrays with high Q class E resonators at 13.56 MHz for dynamic beam steering and efficient energy coupling. The receiver consists of MEMS or NEMS based spiral microcoils on a flexible substrate optimized for high inductive gain.
The system utilizes resonant inductive coupling for mid-range 4 to 7 cm wireless energy delivery with received AC power rectified and regulated on chip. Adaptive impedance matching compensates for detuning, and closed-loop AI control optimizes transmission parameters for efficient power delivery under dynamic conditions.
Thermal management is crucial for safety. Our system incorporates microfluidic thermal regulation with embedded microchannels for convective cooling, phase change materials (PCMs) to absorb heat during thermal peaks, and nanostructured heat dissipation layers using graphene and boron nitride nanotubes (BNNTs) for rapid heat diffusion.
These features ensure regulatory compliant thermal performance with peak tissue temperature elevation consistently below 1.5 degrees Celsius, meeting FDA and ISO standards for implantable medical devices.
We employed a multi-physics modeling framework using COMSOL multiphysics for coupled EM thermal simulation and ANSYS HFSS for coil resonance tuning and EM field validation. This allowed us to assess electromagnetic safety and performance, achieving a SAR of less than 1.5 1.6 watt per kg and demonstrating over 90% field homogeneity.
Thermal safety verification confirmed that peak tissue temperature remained below 1.5 degrees Celsius. Simulation outcomes validated system reliability across various configurations, establishing a robust safety envelope.
We conducted in vitro validation using tissue mimicking phantoms for over 1200 hours to evaluate power transfer integrity, EMI suppression, and thermal diffusion. Real-time impedance tracking confirmed stable coupling efficiency.
In vivo assessment was performed on rodent models over 60 plus days, assessing biocompatibility, thermal response, and device stability. Histopathological analysis confirmed the absence of adverse effects. Regulatory compliance testing showed conformance to ISO 60601 1, ISO 10993 and preliminary FDA Class 3 device requirements with successful bench level assessments.
Our AI optimized dynamic impedance matching using reinforcement learning based tuning delivered a 15% efficiency gain over static configurations and enhanced coupling stability. We also achieved electrical reliability across biological variations, ensuring consistent voltage induction.
Table 1 summarizes power transfer efficiency results showing 85% plus minus 3% efficiency at 5 cm with optimal alignment and 70% plus minus 4% at 7 cm with misalignment with a plus 15% gain from AI tuning. The table 2 presents the safety and compliance summary with results meeting or exceeding safety standards.
Figure 1 shows the efficiency versus frequency plot demonstrating the system's performance across a range of frequencies. Figure 2 illustrates the 3D electromagnetic field distribution, and Figure 3 shows the induced voltage in receiver coil.
These visuals, combined with the data in Table 1 and 2, highlight the effectiveness and safety of our AI-optimized wireless power transfer system.
Our system has some limitations. AI models exhibit limited generalizability across diverse patient profiles without retraining. There is a lack of closed-loop integration with real-time biological feedback, and system behavior under extreme physiological conditions remain untested. Validation is currently preclinical.
Future scope includes integrating biosignal, integrated feedback loops, developing multimodal AI generalization, enhancing edge-level algorithmic optimization, advancing toward clinical trials, and developing spatiotemporal coil array control for precision power delivery.
Thank you for your time and attention. This slides provides a list of references we used for our research. We are now open to any question and answers. Thank you.
Thank you.
Thank you very much, Richie. So we have room for 1 to 2 questions. Anyone? Yeah, actually, just a compliment or a comment. This is a very interesting area, like the wireless power transfer. And also, you made the right choice of using ComSoc Multiphysics, and I'm not making advertisement for them, but also the ANSYS are very good tools. And the topic is very interesting. So we don't have any questions, but certainly we have your paper, and if anyone interested, we have your email too. So thank you again for your presentation, very clear presentation. Thank you. So we'll have a short break, and then we'll come back in, actually, let me check. We'll come back in 10 minutes to close with the last session of the presentation. So please, Garima, and we have also Qasim. Qasim, are you online with us? So I'll just make sure to contact Qasim, but Garima?
Sir, I'll be here on our place.
Sorry?
Sir, I'll be here on our place.
Okay, so you'll be the one addressing the Q&A. Very good. Then please, we'll meet again in 10 minutes to finish the the second part of the presentation. So for the second part, which is the last part of the conference, we'll have 2 presentations online, and the other 2 will be in person by Osama visiting us from UDST from Qatar, and Professor Murugapan will close the session. Okay, great. So we'll see you in 10 minutes. Thank you. So very good. So we'll start. We'll continue actually with the last session of the program. Okay, so we'll continue on applications from the e-health, but mainly this session is called Selected IoT Application. And the paper will explore the therapeutic potential of electromagnetic field exposure from wireless power transfer systems in neural regeneration post-spinal cord injury. So there is also the medical aspect related to post-spinal cord injury. So again, I think Vansaj, yes? Vansaj, you will be covering for Garima, yes? Yeah, for some reason, I need to make sure that we hear you. The volume is not set. Can you speak again, please?
Yes, sir, I'll do.
Very good. Okay, so we'll get started with the recording.
Exploring the therapeutic potential of electromagnetic field exposure from wireless power transfer systems in neural regeneration post-spinal cord injury. This study investigates the potential of electromagnetic field stimulation to provide neural regeneration in spinal cord injury models. Spinal cord injury leads to severe neurological deficits due to axonal disruptions and demyelination. Conventional MRI lacks the sensitivity to detect subtle microstructural changes, especially in early or progressive stages of injury. Diffusion MRI, DMRI, particularly diffusion tensor imaging DTI, offers a non-invasive approach to assess white matter integrity by measuring water diffusion properties. Key metrics such as fractional anisotropy FA, axial diffusivity AD, and radial diffusivity RD provide valuable insights into axonal injury and demyelination, making DMRI a promising tool for characterizing SCI pathology. The study aims to quantitatively analyze diffusion MRI metrics in an experimental SCI model. The objectives are to evaluate the sensitivity of DMRI in detecting microstructural damage, map the spatial distribution of injury along the spinal cord, and identify reliable imaging biomarkers. These findings are expected to support improved diagnostics, monitoring, and translational research in spinal cord injury. Previous research has explored the potential of EMFs in various neurological conditions, including SCI. Smith et al. Demonstrated enhanced axonal growth using an EMF cellular patch, but the scalability of this approach for clinical translation remains a concern. Johnson et al. Found that EMFs can increase cell viability and collagen production, which are crucial for tissue repair, but the long-term effect of EMF exposure require further investigation. Lee et al. Compared the effects of pulse versus continuous EMFs, with their findings suggesting that pulse EMF may be more effective in stimulating cellular activity. Taylor et al. Demonstrated that pulse EMF can improve neurological function and reduce inflammation in SCI models. However, a significant gap exists in our understanding of the inflammation specific effect of EMF generated by WPT systems, which are increasingly used in implantable medical devices. Our research aims to address this gap by investigating the therapeutic potential of WPT generated EMFs in SCI. Our methodology involved in vivo experiments using adult male Sprague dolly rats. We induced SCI at the T9 spinal site using a standardized contusion
injury model. Following SCI induction, rats were exposed to EMFs at a frequency of 13.56 MHz and an intensity of 10 megawatt per centimeter square for 2 hours per day over a period of 4 weeks. We compared the effects of pulsed 1 Hz and continuous EMF modes to determine which stimulation pattern was more effective. To assess the effects of EMF stimulation, we employed a comprehensive approach that included behavioral assessment, electrophysiological recordings, histological and molecular analysis of spinal cord tissue, and computational modeling. The experimental design involved a detailed timeline of EMF exposure and various assessments. Following SCI induction, rats underwent daily EMF exposure for 4 weeks. Assessments were conducted at specific time points throughout the study, including behavioral tests to evaluate motor function, blood sampling to measure inflammatory markers, electrophysiological recordings to assess neural activity, MRI to visualize tissue changes, and tissue collection for histological molecular analysis. These analyses allowed us to examine cellular and molecular changes in the spinal cord. Table 1 provides a detailed overview of experimental groups and assessment schedule. Table 2 outlines the specific EMF parameters used in the study, including frequency, intensity, and exposure duration. Our quantitative findings revealed significant differences between the EMF treated groups and control groups. Specifically, the pulsed EMF group exhibited a significant decrease in lesion volume as measured by MRI compared to the control group, indicating a reduction in tissue damage. Axonal and myelin markers quantified through GAP4-3 and MBP staining were significantly higher in the pulsed EMF group, suggesting enhanced axonal regeneration and myelation. Qualitatively, rats treated with pulsed EMF demonstrated improved coordination and mobility compared to control group as observed during behavioral assessments. Histological evidence further confirmed enhanced axonal sprouting and myelin preservation in the pulsed EMF group. We also observed a reduction in inflammation in this group, indicated by lower astrocyte and microglial activation, suggesting a neuroprotective effect of pulsed EMF. Our findings demonstrate that pulsed EMF stimulation significantly enhances recovery following SCI in rats. Pulsed EMF promotes a neuroprotective environment facilitating tissue repair, axonal regeneration, and functional improvement. These effects are likely mediated by a reduction in inflammation and upregulation of neurotrophic factors, while the precise mechanistic pathways underlying EMF induced neuroregeneration require further elucidation. Our results strongly suggest that pulsed EMF therapy holds significant potential as a non-invasive adjunctive strategy for promoting neuroregeneration and functional recovery after SCI. It's important to acknowledge the limitations of our study. First, the study was conducted on a single animal model, rats, which may not fully replicate the complex pathophysiology of human spinal cord. Second, the observation period was relatively short, 28 to 35 days, which limits our understanding of the long-term therapeutic effects and durability of functional recovery following EMF treatment. Third, we did not perform a dose-response analysis for different PEMF parameters such as frequency, intensity, and duration, which restricts our insight into optimal treatment condition. Finally, the precise molecular and cellular mechanism underlying PEMF-induced neural repair remain incompletely understood. To address these limitations, future research should extend studies to larger and more diverse animal models and eventually to clinical trials for human application. It is also crucial to investigate the long-term effect of PEMF therapy and the potential for chronic application. Here are the references used in this presentation. These studies have contributed to the body of knowledge upon which our research is built. Thank you for your time and attention. I am now happy to answer any questions you may have.
Thank you very much. So we'll check if we have any questions. So yeah, again, it's a very interesting topic here. When it comes to the frequency, what frequency you use, that's the first part of the question. And what can be or what could be one of the effects on the cells. So we know that using such technique may be risky. So did you discuss with experts about the feasibility on humans?
Yeah, hi sir. So thanks for the question. So as discussed with the experts from biotechnology field, we with positive impact we had an frequency of 13.56 megahertz, which will enhance the cellular repair for spinal cord. Also, it will not have a modulation of neuroinflammation. So our potential mechanism had this neuroinflammatory signaling modulation effect, which is discussed in PPT for the expression of neurotropic features. Our expert also suggested non-thermal effects of this frequency as asked by you.
Please, if you don't mind repeating, what was the frequency?
Sir, 13.56 megahertz.
Okay, no problem. I'll double check it in the paper. But again, thank you very much for the great presentation, and we'll move to the next one. Thank you.
Thank you so much.
So we have the next presenter, Qasim Danach from Lebanon. Just making sure that Qasim is online with us.
Yes.
How are
I'm
you,
here.
Qasim?
Fine, alhamdulillah.
Very good. So we'll start your video, and then we'll ask you questions, okay?
Yes.
I
Go ahead.
appreciate it. Thank you.
Hello, today I will present my paper titled Adaptive Hyperheuristic for Smart Logistic Optimization. So, first of all, the outline of this presentation, I will start with the motivation and the research objective. Then I will explain the optimization technique and some background, then the solution approach, which is hyperistic techniques. Here I will explain the concept, the classification, and also the evaluation of hyperistics. Then I will present the proposed framework, which is consisted with LLH, low-level heuristics, and the heuristic selection methods, the acceptance criteria, and the determination criteria, and I will explain the overall workflow. And then I will present experimental results on a set of benchmark datasets, and at the end I will conclude and present future works. So first, about motivations, we know that logistic problems are increasingly complex. So we talk about examples like vehicle routing problem, scheduling problem, hub location problem, facility problems, and so on. And the traditional meta-heuristics like genetic algorithms, simulated annealing, ACO, PSO, so are effective but need heavy tuning and need in general adaptive and automated optimization approach like the proposed one in this presentation. So our objective here is to introduce a reinforcement learning based hyperheuristic framework. So this framework is a general purpose tools for all combinatorial problems in logistics, and it will be scalable, adaptive, and for sure domain independent and minimal human intervention. So first, When we talk about optimization technique, we have two categories: exact method and non-exact methods. For exact methods, it's methods um, based on mathematical formulations. So it's provide probably optimal solution, but one exists. So we work on uh, small instances, small sizes, because it need big memory, actually very big memory. So for this reason, we mention when they exist. The second category is non-exact methods. Here we don't have guarantee for the solution quality. So about non-exact methods, we talk about heuristic, meta heuristics. Here, when the techniques um, use two different concepts about intensification and diversifications, like exploring and exploiting the domain research. And then meta heuristics, which is combination between heuristics or meta heuristics or even hyperheuristics plus an exact methods, so plus mathematical formulation or mathematical techniques, and finally hyperheuristics, which is defined as a heuristic to choose heuristics. So we are interested for hyperheuristics, which is a methodology for searching the feasible space, which is generalized by a set of low-level heuristics, which are actually the part that are domain dependent to the problem. And it's also a method for automation of the process of selecting and generating multiple LLH low-level heuristics. So it goes a step beyond meta heuristics, and particularly is that their search space isn't the usual space for the solution. So the search space is heuristics or meta heuristics itself. And the search method and learning mechanism in order to select or generate the heuristics. Here in our research here, we are interested in the first category of hypeuristics. So we are interested to select the best series of heuristics in order to obtain the good enough solution. So about the HH and in final words, the final objective is to design and generate methods which can be applied to several domain problems. So hyperheuristics is categorized as online and offline. So this classification is based on the learning mechanism if is active during the solution process or not. Here also we talk about the feedback source, if it will be during the research or not. And also we talk about the nature of a heuristic space and the LLH type, if it's يعني, based on what the objective of LLH and so on. So the framework of LLH is based on the we have a part which is domain dependent called LLH, low level heuristics, and also we have acceptance criteria. So when we have a new candidate, new solution, so if we accept this candidate or not, so we should define some rule to accept the new candidate, the new solution during the search, during the process or not. And then we should define when the process will be terminated. So here we define something called termination criteria. And also we should define the selection rule. So we defined and the rule based on how HH will select the LLH. So about LLH here defined in our work, just to test the framework. So LLH is or our LLH are categorized as constructive heuristics. So the aim is to construct solution from scratch. And we have another category called improvement as local search. So the aim is to improve the quality of current solution. And then we have another type called perturbation. So to do some random action to the current solution in order to avoid a local optima. So about the heuristic selection method, which is a dynamic learning based strategy. So we use reinforcement learning to select the best low level heuristic at each step. Here we define something called MAB, multi-armed banded problem. So it's based on such formula which is related to the average reward of heuristics and the number of time of the heuristic was used. And also we define some ratio exploration parameter that balance the exploration and the exploitation, the intensification and the diversification during the search. So heuristic with the highest UCB score is selected as at each step. So the balanced exploration and exploitation, the framework utilizes an adaptive acceptance criteria. Here we define three criteria. The first one is improved based acceptance. So always we accept the new solution if it improve the objective function. So if it's have better quality. And the second one is simulated annealing based acceptance. We accept the worst solution but with a certain probability. And the last one is stagnation based diversification. So if we have no improvement is observed over predefined number of iteration, so a large mutation is introduced to diversify the search. So the overall workflow, the first we generate an initial solution using the constructive heuristics, and we have a loop while the termination criteria are not met. So we start with select a low level heuristics based on UCB heuristic selection strategy, apply this LLH to the current solution, and then evaluate the candidate solution, and then accept or reject the candidate solution and update the UCBs. So about our results, the result indicate that the best performance is achieved when see here in this chart is 1.5 with an average objective is 798.2 and the lowest standard deviation of 4.3. So smaller value of C result is insufficient exploration, while larger value lead to excessive exploration degrading performance. And we show the difference between the HH performance and GA. We have minimum improvement 5.56% and maximum for in VRP problem with the time window 9.02%. So also the result confirmed that the proposed framework maintains stable performance. So the average standard deviation range from 4.3 to 6.1, highlighting its robustness in dynamic and stochastic environment. So here we conclude. So developed innovative heuristic framework for smart logistics, solve complex combinatorial optimization such VRP and GSSP, and achieve high general adaptability via domain agnostic heuristic design. So use the UCB strategy for intelligent heuristic selection and balancing the intensification and diversification. So the outperformed our well-turned GA and solution quality, stability, and robustness. And in our future work, we should address real-time and stochastic logistics scenarios and integrate multi-objective optimization and also apply deep reinforcement learning to generate adaptive heuristic and dynamic uncertainty environment. Thank you so much.
Thank you very much, Dr. Danash. So let me check if we have any questions from the audience. Let me check with Dr. Hassan if he has any question. So he says salam to you. Dr. Hassan is here.
Salam, Dr. Hassan.
So we'll have a quick question. Now, when it comes to all of these heuristic algorithms, I see that you compute a function, which is great. Now, when it comes to the complexity, did you measure the complexity of different algorithms?
Yeah. So first of all, salam of all. Second, about the complexity, for this reason, actually, we did the non-exact method. So if we apply exact methods, so the problem come to be NP-hard. So with this kind of non-exact methods, like the proposed solution, which is called a heuristic method, so the problem is isn't NP-hard methods, and the time is reasonable. So if you look to the response time, for example, so all instances, in all instances, the response time doesn't exceed 7 seconds, even if we have a big size of instance.
Very good. I mean, like the main reason behind my question is because you presented different, like the heuristic, the meta-heuristic, the hyper. So mainly, just wanted to have an idea. Did you reduce it from NP-hard to polynomial complexity or whatever? I think it's worth having such comparison, but you did actually address my question very well. So thank you so much, Dr. Danash, for the great presentation and for the great work. And we'll move to the next presentation by Osama Mokashi. So Osama is visiting us from UDST, University of Doha of Science and Technology in Qatar. And he will be presenting a work on systematic review on real time. So this is a big project collaboration with Bangladesh, and it's very useful project in agriculture. It's not really agriculture. What do you call this?
Under agriculture.
Under agriculture. Okay, so let me start the slides for you, and if you want to have the pointer, yeah, I'll get you the mic and. Actually, we lost the mouse. The mouse is gone somewhere.
I think the trackpad is off.
Let me escape.
Oh, it's stuck.
It's stuck. For,
maybe lock it. Now it is off.
now you put us in trouble with it. Haritha, just.
Now it will be faster.
Yeah.
At least.
You can start the presentation from your memory and then.
Okay, no problem.
Does it have a password?
Can I have a mic?
Start, introduce yourself, and I will get you the mic.
Caps, right? What needs to? This is PC is locked out. Tell me the password.
Assalamu alaikum wa rahmatullahi wa barakatuh. Good afternoon, everyone. I'm coming from University of Doha Science and Technology, Qatar. So we have a project going on dairy management, real-time monitoring of cattle. Basically, it's about the systems and the sensors integrated with IoT to monitor the cattle management system. We integrate IoT sensors on the cattle, basically, to analyze the important vitals of the cattle, like DC2. So the So we implement sensors, IoT-based sensors, to detect important vitals of the cow, to for early detection of diseases or any abnormalities coming up in the future. So our paper, a systematic review on cattle management systems, is basically a system which gives a sample of what a system, entire framework of IoT-enabled sensors will look in the future. So this is one of our works in University of Doha Science and Technology. Here we mainly focus on introduction, literature review. We have the IoT-based cattle monitoring system, the framework, and the infrastructure. We are focusing mainly on the sustainability impact as the solutions already exist, and we want more sustainable solutions in the future. Before I start, I just want you guys to remember 3 words with me. Negligence, inefficiency, and sustainability. So we have negligence, inefficiency, and sustainability. Just remember these 3 words. Let me paint you a picture. This is a classic cow barn, you can say, or a cow farm. Let's go to the past. A traditional cow barn or a farm has no sensors integrated in it, has nothing inside, just a basic thing. The dairy farmer or the side worker manually checks the cows every day. Back in India, like we have, some of them just check them every morning while milking or like while they go and close the sheds. So here the main parameters, what is missing out is early detection of illness or abnormalities of the cows cannot be detected by the farmer every day. Like he has to check around 10, 20 cows in a day maybe. So this system is negligent, we can say, because negligence of the dairy farmer, we can say, negligence of the health of the cow, negligence of the technology to be used. And the farmer is confused how the illness happened or what happened in the future. And again, the main parameter is that this can lead to a lot of monetary losses per cow. So it's around, you can say for humans it's expensive, the healthcare. Imagine for animals, imagine for cows. And a cow, subhanAllah, is an amazing creature. The digestive system of a cow is very complicated. And the main point here, drop in milk yield. Milk production drops. The milk production dropping is the main factor. And this factor has been studied by various researchers in the past and the present as well. So let's come to today's scenario. Today we have various sensors integrated. We have an app system where the farmer can track what is happening. The app shows the cow is resting. The app shows the cow is, there's an alert. So the farmer checks which cow has an issue, what is the problem, and how can we fix the solution. And one of the cow is moving. So the cow is happy, the farmer is happy, he has a system, and he's running the system entirely. But here, there is negligence again, and inefficiency again, because system is integrated, but they are not looking into the sustainable parameters. I'll talk about why sustainable parameters are important, and here again, technology is being implemented everywhere now in cattle farms, cattle farming. Various systems across the world have. But to have an efficient system with modern technologies, with modern communication models, because it's always a developing structure. Moving on, we have the future. The future will have a fully autonomous structure, fully automated dairy farm, less staff, minimalized. Everything is simple, the process flow is aligned, the structure is aligned. From this, we are going to this. And this is AI again, AI-generated image. I'm sorry for this image. It's milking, but it's catching the tail. AI is not perfect. So here we are meeting three main important factors: reducing staff, inefficiency, and we are meeting the sustainable development goals. This is very crucial because in the future, methane emissions, greenhouse gas emissions, and other related efficiencies like for food safety, it is important. Qatar is working a lot towards the food security call. This project actually comes under the Qatar food security call. We met the sustainability goals in this, we are focusing on them, and why? Why are we focusing on sustainability goals? Greenhouse gas emissions in livestock production or in dairy and cattle is around about 57%. It's more than the transportation industry combined. Around 7.1 gigatons of carbon dioxide, followed by methane emissions. Other than that, we have monetary losses again, because healthcare is expensive for everyone. Even for animals, veterinary costs go up to $100 to $1,000. And the diseases are a wide range of diseases cows face, actually. It's just not like a simple disease. They have milk production, there's rumination issues, there's digestion issues, etc. So it is an expensive cost which will affect the entire farm setup. The real need for the future, what we can say is the rising demand for meat and milk production, it's really high, and it's predicted to go more by 2030 as well, and the Sustainable Development Goals are highlighting it everywhere. So in our paper, we are just reviewing simple wearable sensors which can be optimal, which can be beneficial, which can be more optimized for a better system, a sustainable system as well. We focus on PLF, precision livestock farming. This one combines everything. This one has the automated system, the environment factors, the autonomous factors. And these sensors are studied in various parameters. This is our keyword from the references which we are working on the papers. With the cattle, there's a lot of intercommunicate domains linked with the study of cattle and dairy farming. So our solution here is based on the neck collars. We are focusing on neck collars. These are the systems which are there worldwide. And the main factor we focus on is we don't have so much solutions in Middle East. So Qatar is planning to have their own local home-based solution. As they have started their own dairy systems, dairy companies, they're producing their own produce very well. And you guys know the success story of Qatar with the milk production. So this, in my hand, for example, is a small sensor setup. This one detects, this will be on the cows actually. Just with a small strap, it goes on the cows. This is 3D printed model. So these are the results that come out. This is just a simple implementation. At a higher level, it's a different implementation. So the IoT framework just starts with the sensor deployment, what sensors you want to use, what are the optimal sensors available in the market, which can be integrated in the system. Connectivity comes where the communication protocols, BLE, LoRa, which is efficient, which is the range, and what can be the most energy efficient solutions. Even the edge processing, moving on to the cloud integration, we have various solutions available in the market now, which can be leveraged and which will be the best for the future. This is a simple infrastructure, how the system is integrated. And this is one of our work in progress which is going on, because here we are focusing on greenhouse gas emissions a lot. And important factor of sustainability, enhancing sustainability, reducing, sustainability works well, works in hand with technology as well. Because we are reducing the veterinary cost, higher productivity, milk production, even the meat production is involved in these factors. So to conclude my presentation, this integration, what we have studied in the paper, we just review what technologies are available, what can be leveraged, and what future can be developed out of this. And these technologies have given good results. They have proven results of increasing productivity, detecting diseases early in cows, and detecting abnormalities. Even if a cow is not walking properly, the algorithms are developed to capture the improper movement, which can lead to limpness or diseases, and even other big issues with the leg movements, which can cause bacterial infection in the cows. Main objectives of our Qatar project is we are focusing on estrus cycles, livestock vitals, monitoring cattle weight, injuries, and vitals accurately, and we are working on real-time greenhouse gas emission and methane emissions again. And the entire system will have machine learning capabilities for data collection, presentation, and a final dashboard, which will have everything. So this project, as I said, Qatar local project. It's funded by QDRI under Qatar National Research Fund. So sustainability, we have to have a limit with sustainability and IoT integration. You can't say, okay, we'll integrate IoT. I had a debate with Dr. Zaid yesterday. He said, not a debate, a discussion. He said, why you want to put so many things on a cow? Let it be free, let it move around. We agree, but humans make errors. And for every time, like in a big setup, a human dairy farmer cannot catch everything. So this is too much actually. We have to just stick to this. We don't want too much additions in the name of IoT and sustainability. That's all for me. Thank you very much.
Thank you very much. Really interesting presentation. So, do we have a question? It doesn't work well, so but
you can take my mic. How will I speak then?
Yeah, I was reading an article. You may get it as a joke, but happy animals are productive. So it's indeed either the quality or then probably you need to start a project about sentiment analysis for cows or something like that. But this is another topic. Any questions that more relevant than mine? No. Yeah, very interesting presentation again. Thank you so much.
Thank
Osama.
you.
Thank you. Okay, so we have our last presentation of the conference by Professor Murugapan, and it will be about AI-driven anomaly detection in textile manufacturing using IoT and deep learning. So let me start the slides for you, and the floor is yours.
Very good afternoon to everyone. Yeah. So I thank Ziad for giving me a first presentation on the first day, last presentation on the second day. Anyway, since the time is running up, I want to quickly summarize what is all about our work. And it is one of our collaborative work between KCST and Watson University in India. And the system has been, the IoT-based defect detection system has been implemented in a textile factory in Andhra Pradesh, India. And I'm just going to summarize. So the outline of the presentation starts from introduction, problem statement, the motivation, related works, methodology, architecture diagram, and results and discussion, conclusion, and references. So I don't want to read the slide, I just summarize what we are trying to do and what we have done. So when you talk about the textile industry is concerned, the defect detection is one of the very, very important thing. So there are a different kind of defects is possible when they are producing the cloth or fabric. And also there are a different type of fabric also has a different type of defects. So we need to identify or develop a system because the manual detection is highly limited and it also gives a human error, and the accuracy of detecting the defect by manual method is usually very low. So we want to develop an automated system by using the IoT sensors and AI methodology to speed up the computation of the detection of the different type of defects in the textiles, okay, textile fabrics. So in this work, what we have done is we used the 3 different deep learning or 4 different deep learning model, ResNet 50, Efficient Net B3, Vision Transformer, and Autoencoder. So these models are mainly useful for processing images from a different type of sensor. That is the main purpose, why we have this many models. And we are able to achieve around 99.1% accuracy in terms of detecting 12 different types of defects in a fabric. 15 defects in 12 different types of fabric. And in this work, what we have used is we used a high-resolution RGB camera for detecting the normal defects or textures defects in the cloth. And we used infrared sensor. Infrared sensor is basically a FLIR camera, thermal camera, that is used to detect the thermal or any spots. And ultrasonic gadgets also used to detect the uneven pattern. And high-resolution camera is used for detecting the color, shading, or any other defects in the cloth. So the way, the accuracy, how we managed to achieve this accuracy is because we have used the offline processing unit, edge unit, and also we have a cloud unit. Whatever the defect that we can detect it by in a very quick way, in a shorter time, we do it in offline. And whatever the images that need a further processing, that is sent to the cloud for processing the images. Okay. So the problem statement is the same. So we want to automate the defect detection system in textile industry. We want to improve the accuracy of detecting the different type of defects. And also we have to scale up the model for any size of the textile industry, because there are some industry, they produce a few smaller volume of textile cloths. Some industry, they produce a mass producer. So we need to always develop a system which can be scalable. That's the main purpose. And there are plenty of earlier work has been reported in the literature, but most of them have used the hand-picked features. That means they take an image from the cloth, they extract some statistical parameter, and then they use the AI technology or AI algorithm to classify the defect. So this is totally time consuming, and also there are chances for getting an error, and accuracy of the deduction maybe go very low. And most of the people have used the machine learning classifiers such as support vector machine, random forest, and KNN. And those methods offer a very low accuracy, and also it is not capable of handling a large volume of data. So when you go for real-time system development, we need to have a system that can handle a huge amount of images in a fraction of second interval, In this case, there are also some deep learning models have been proposed, but the accuracy of those systems are limited. And most importantly, the number of defects considered in the system also very, very few. So these are all the basic limitations. So to overcome that, we have identified a gap, a research gap, to develop a real-time system, and also by using a multi-sensor module for detecting a different type of defects, and also to make a system which is scalable. That is very, very important, So as I just go to the system is concerned, design is concerned, as I mentioned earlier, we use a normal RGB camera, and also we use the infrared sensor, which is FLIR camera, and ultrasonic gauges, which is a through ultrasonic sensor, to detect the different type of defect, and those images are collected, and that has been processed through the conventional filtering technique to remove any noises or any backgrounds. And then we use the augmentation technique to to enhance the number of images which is used for developing or training a model. And then we use the NVIDIA Jetson Xavier server for edge device to process the images. And finally, we have come up with the GUI, which will help the textile industry people to understand what are the type of defect and what is the location, where is it located, everything they could easily identify it. And as far as the system accuracy is concerned, even though we developed an ensemble model by combining a deep learning algorithm with a machine learning model, we also tested individually on a different deep learning model. As far as the accuracy is concerned, all the models are able to achieve more than 95%. However, the ensemble model has reported a very high accuracy. And the total number of images that we used in the system is 4,595 images we have used. And the system is able to detect the defect in 27.6 milliseconds. So it is one of the notable achievements in the case of multi-defect detection system. And there are some sample images I have shown on the right side, which is shown the different types of defect, where it is located, and what is the size of the defect. Even we can detect the size also. The proposed system is able to detect the defect which is less than 1 millimeter. So that is the accuracy of our proposed system. And the fastest response also we have achieved in terms of getting a decision from the entire system on finding the defects. And the complete system has been implemented in a textile factory in Andhra Pradesh in India. And we have achieved about 99.1% accuracy of uptime in the industry over a period of 3 months' time. And it also gives us the opportunity to explore the further avenue to scale up the system and also to enhance the system performances. In future direction is concerned, we want to address the energy efficiency. So since the energy consumption of this device is about 45 watts, so we need to develop a system which consumes lesser energy. And we want to also develop a deploy it on a physical IoT devices to develop portable models. And we also interested to implement a quantum computing technology, because the defects are having a very difficult and complex pattern. Compared to the conventional deep learning model, the quantum machine learning or quantum learning models are able to handle complex patterns. So it also gives us the avenue to develop a model in quantum computing platform. At last, we want to develop edge integrated IoT security solutions for the proposed system. And these are all the references. Thank you so much for your time and patience and interest. And since there is no time, if you have any questions, I'm happy to answer.
Thank you very much, Professor Murugapan. So we have questions.
This is the first, the last question. Working, huh? Okay. The question is related to slide number 7, where you mentioned that VGG is actually not optimized for real. You see the challenges in the VGG and ResNet. It's not optimized for the real-time performance. But VGG and ResNet, both of them are a transfer learning technique, and both of them are good for real-time performance. So can you somehow elaborate or giving us an example that why it is not good for real-time performance, the VGG and ResNet?
One of the biggest complexity in VGG is the model, the number of training parameters are very high. So usually the model is very, very complex, and also it takes more time. That is one of the reasons we have not included it.
But in simple network, on the other hand, also required a lot of training time.
Yes, yes.
So this means that the VGG or ResNet is like almost closer in performance with the in symbol, right?
Yeah, actually here, since we are using a multiple sensor on multiple data, so we have tested with a few combinations. Since the VGG is concerned, we have a different history of models, different versions of models are available. But when we are doing in our testing, we didn't get a much better performance. Probably we will consider your suggestion. Yeah, thank you. Thank you so much. Yeah.
Any other questions? Okay, so thank you very much, Professor Murugapan. So now I invite the conference co-chair, Professor Mohammed Trabilsi, to give the certificates for these session presenters, starting with Dr. Ismail Ardhawi. Next, please, if you can stay on stage for a group photo, and then we have Dr. Hassan Kazan. Next, our guest from UTST, Osama Mukashi. And Professor Murugapan, please. Okay, so I'll give the opportunity now to Professor Trabilsi to start the closing ceremony.
Slides are there? Huh? Slides are there? Okay. Assalamu alaikum, ladies and gentlemen, dear colleagues, dear students, good afternoon. First of all, please allow me to share with you my proudness to witness the growth of S4IoT into a vibrant and impactful conference, bringing together diverse voices to shape the future of smart, sustainable, and secure Internet of Things. As we reach the end of the second edition of the S4IoT conference, I would like to take a moment to reflect on what has been truly an exciting and inspiring 2 days. So in this year's edition, we were proud to host 30 technical presentations presented both online and in person. 3 inspiring keynote speeches by leaders, by expert leaders, 2 engaging panel discussions, 2 hands-on workshops, and 1 vibrant poster exhibition showcasing more than 60 posters from KCST students and researchers across Kuwait. So now, before we move on to the awards segment, I would like to ask Professor Khalid Al-Baqaeen, the President of Kuwait College of Science and Technology, to join me on stage and to deliver his official closing address.
Thank you, Doctor. I can't say more than what Dr. Travis said, that I feel so proud that this initiative that we started last year has come to such a beautiful conference. Over the years, I have had many conferences. So the conference I attended, probably Dr. Abdullah Ghalaf will share with me, we attend a lot of conferences. I don't think I can tell number, but they are above 100 conferences, definitely. But to see KCST coming to this level, where to organize such a fantastic conference with a fantastic keynote speakers who are coming to give insight into what the future looks like, as well as amazing technical sessions, make me feel that we are on the right track. And I hope this will continue to make KCST a platform for research and learning in Kuwait and in the region. I don't want to repeat what Professor Travelsi said. He gave the numbers, and they're impressive numbers, and we know that. And what is impressive is to see so many people in the closing ceremony. In many conferences I attend, at the end it's just the speakers of the last session. But now with this competition that we created, we see the students sitting at the end. It's a great achievement. So I want to thank everybody who got involved in this, from the people who came up with the idea, Professor Trablisi, Dr. Ziad, Dr. Murad. I don't want to mention names because I know that I will forget. Yeah, Ismail and everybody who has been on the committee. They did an amazing job. The only regret I have that I was not able to sit through all the conference as I usually do. This time I had so many other things, but it has been a really rewarding. I was hearing how excellent was everything here. So congratulations to everybody. Thank you for everybody who's contributed. Thank you to IEEE Kuwait section for supporting us, and for also the Kuwait Information Technology Association. We look at these conferences as a way for us to work together to promote research and to enhance research in Kuwait and prove to the world that Kuwait has great potential to become a place where great ideas happen and great gatherings happen. The other thing that I was very impressed with was the exhibition of the final year projects that was there. To be honest, we had the representative from the Private Universities Council. If I've had known that this quality of the presentation, I wouldn't have let him go, because he had to go because he had a meeting. But I went through it. I saw half of the projects. Tomorrow I will go to see the other half. It's inspiring. It's amazing. I'm very proud of every student who produced such a fantastic work. We see you come to the university as young, 18 years old, young people who sometimes they don't know why they are coming to university. And then later we see engineers who produce great ideas, who create projects, and you fill us with pride. You pay us back the effort that me and all my colleagues are doing here. So I'm using this opportunity to thank everybody, including the students. Thank you for being excellent. Thank you for your commitment. Thank you for the work that you do for us and the work you will do for Kuwait, because Kuwait deserves your effort, deserves your excellence. So thank you very much.
Okay, thank you, Professor Khalid. So now I hope that the slides are put in order so we don't kill the suspense. So so we'll start the closing and award ceremony. We'll start with the best paper award, and we will start with the third place. It goes to the poster titled Next Generation IoT Connectivity, RSO RF Integration with High Attitude Platforms for Reliable Data Transmission. I'm asking the students of this poster to join us on stage. Sorry. Yeah, this is. So again, we killed the suspense because we are supposed to have the best poster award first. Congratulations, Dr. Bassem. Sorry for my bad. Yeah. Okay, so now we'll move to the poster winners. The third place will go to the poster titled IoT-based bracelet for epilepsy management. The students are Mish'al Ahmed Al-Sha'lan, Saoud Marzouk Al-Saadi, Muhammad Saad Al-Rashidi, Abdul Rahman Al-Ali, and supervised by Dr. Abdul Latif Baba. Is Dr. Abdul Latif Baba here in the audience? No. Second, so basic mathematics learning virtual reality game for pre-schoolers. Authored by Isra Ayoub, Hibatullah, Zahra Abdul Jalil, Shah Al Hussein, and again supervised by Dr. Abdul Latif Baba. And now the first position goes to Muhammad Trablsi. No, I'm joking. Advancement in IoT integrated nano-based drug delivery system for therapeutics. So authors Joyce John Sharafuddin, Dr. Sharafuddin. So if could you please remain on stage so we'll have a group photo with the winners, please? The poster winners and the best paper award. And now, before we wrap up, so we would like to recognize the huge effort of the organizing committee. So Professor Khalid, also please be with us and remain on stage. So now we would like to give a token of appreciation to the organizing committee. We'll start by the conference co-chair, Dr. Murad Khan. Please join us on stage. Thank you, Dr. Murad. So now we'll move to the program chairs. We'll start with Professor Murugapan. Please join us on stage. Thank you, Professor. Dr. Ziad Bouida. Dr. Ismail Ridawi. Would like also to thank our publication chairs, Dr. Basim Abdelaziz, Dr. Nader Shahata, no problem, no problem. Dr. Julian Weber, Dr. Rabi Agustin, our exhibition chairs, Dr. Ahmed Arafa, Dr. Omar Adam, and best for the last, our publicity chair, Dr. Basil Uthman. Okay, let's have a group photo, please.
And our vibrant organizer, the chair of the conference, Professor Mohammed Trabilsi.
Yes, James Bond School of Engineering. Yes. No, engineering.